5 are there. Let me increase the volume. Okay, so now welcome to the agricultural chemistry course module. And here I have in your LMS, I have uploaded the course module, so you can refer the course module and the lecture notes, what I'm planning to do today. So here, so the first part of this module will be done by myself, and the second part of this module will be done by Dr. Geeti tomorrow. So you have to join both classes today and tomorrow. Let me share the course module first. In this course module, we have chapters. So let me move. Yeah, these are the chapters. So the chapter 1 is a just introduction. So the role of chemistry in food and agriculture. So you can just go through the chapter and you could understand what is the importance of chemistry in different fields, especially food and agriculture. Then we will move to the discussion on matter. In chapter 2, what is matter and different states of matter and the mixtures like that. And then third chapter, we will discuss units and measurements. So what are the basic units and measurements that we are dealing in chemistry, not only in chemistry, in other field as well, but we'll discuss about the importance of the units and the unit conversions and handling of the numbers, scientific notation, significant figures like that. And under chapter 4, we'll start our discussion on atoms and atomic structures. And then the periodic table, ආවර්තිතා වගුව, පරමාණු ගැන, units ගැන, පදාර්ථ ගැන, මේ ටික තමයි අපි කතා කරන්න බලාපොරොත්තු වෙන්නේ. Okay, I forgot to start the recording, I think. Let me start recording.
Recording in progress.
නැත්තම් මට කියන්න share වෙලා නැත්තම් කියන්න. මොකද මේක එක windows ඇරුණාම I couldn't see what is already shared or not like that. So please inform me. Anyway, I will let you know again. My God. Now can you see the handbook?
Yeah.
Okay.
Yes, ma'am.
So in this course we have 10 chapters. So I'm explaining it again. And out of this 10 chapter, the first chapter is role of chemistry in food and agriculture. So you can read it and understand what is the importance of chemistry in food and agriculture. Under chapter 2, we will discuss on matter. What is matter? පදාර්ථ ගැන අපි කතා කරනවා. පදාර්ථය කියන්නේ මොකද්ද? ඒකේ different states මොනවද? එතකොට what are the mixtures and their properties like that. We'll discuss under matter. And under chapter 3, units and measurements, basic units and measurements important for chemistry. And chapter 4, atoms and atomic structure, පරමාණු හා පරමාණුක ව්‍යුහය ගැන කතා කරනවා. Under chapter 5, periodic table of elements, that is ආවර්තිතාවගුව, and the properties, how these different properties are changed in periodic table. Then chapter 6, chemical bonding, අපි රසායනික බන්ධන ගැන කතා කරනවා. Chapter 7, mass relationship in chemical reactions. So that means so this is important for the calculations. What is mole? මෝලයක් කියන්නේ මොකද්ද? What is Avogadro number? What is molarity? මෞලිකතාවය කියන්නේ මොකද්ද? So we'll discuss them under chapter 7. Chapter 8 basically designed for overview of food chemistry. So we'll give kind of an overview related to the food chemistry. And 9 agrochemicals, and 10 is the quantitative chemical analysis. Under quantitative chemical analysis, basically we will discuss quantitative analysis, 3 different quantitative analysis based on volumetric analysis, that is titration, anumapaniya. And the other one is instrumental basis one. Using spectrophotometer, we are going to find out the concentration of unknown solution. And finally, paper chromatography techniques, that is used to separate a mixture using paper chromatography technique. And those 3 practicals will be done physically in the faculty. So we will notify the date for the practical session. For the practical session, both groups, Saturday and Sunday, should be attend on the same day. So probably it will be a Sunday. And that is very important because for your chemistry course module, you have a theory paper and the practical paper. So the practical, you have to pass both practical and theory. Therefore, it is essential to participate in the practical session. Then you could understand what are the practicals that we are going to do and the other important things. So your assignment will be basically based on the chapter 9, that is agrochemical. So in today I will discuss matter, chapter 1, atoms and atomic structure, units and measurements, periodic table, and the quantitative chemical analysis. And tomorrow, Dr. Geeta will discuss chemical bonding, mass relationship in chemical reaction, overview of food chemistry, and the agrochemicals. So, and each and every chapter, there are review questions. So please go through these review questions before the examination. That would be important for your examination. Your questions in the paper will be based on these review questions. So let's start the first lecture today. And I will upload the lecture note as a summary. You can take them as a summary of each and every chapter. And if you need any further information, you can refer to the course module. can you see the presentation right now?
Yes, Miss.
Okay.
We can't hear, madam.
Yeah, now I'm still sharing the document, making PowerPoint. My computer is a little bit slow, that's I think now it's in a presentation mode. Okay, so what is chemistry? Chemistry, if you are talking about chemistry, chemistry is the study of matter and the changes it undergoes. පදාර්ථය හා පදාර්ථයේ වෙනස් වීම ගැන තමයි අපි chemistry වල කතා කරන්නේ. Chemistry is the study of matter and the changes it undergoes. So what are the changes? So the changes could be happen in the form of composition, structure, properties or energy changes. සංයුතය හරි, ව්‍යුහය හරි, එහෙම නැත්නම් ඒකේ ගුණාංගවල හරි, එහෙම නැත්නම් ශක්ති වෙනස් වීම වල හරි මේ වෙනස්කම් ඇති වෙන්න පුළුවන්. So the chemistry means so understanding all these changes, the structure, properties, energy changes, and the composition. So then, chemistry is often called the central science because basic knowledge on chemistry is essential in different fields. So it might be chemistry. So when you're talking about day-to-day life, so everything in all around are certain chemical changes. So in your body also certain chemical reactions are going on at the moment. So you have already take your breakfast. You have already have your breakfast. Now something is going on in your body. So that is a kind of a chemical reactions going on in your body for the digestions of your food and for the absorption of your nutrients. So that is biochemistry. So something inside your body, it's going on chemistry. So when you're cooking, so you have done certain chemical changes to the composition of the material or the things that is present in your food. So that is also chemistry. And when you are looking at around in the nature, so something is going on and everything, every moment, we are dealing with chemistry. Something is going on. So the chemical changes are always happening all around you. So we cannot talk about anything without chemistry. So it is essential to understand basic principles of the chemistry in order to dealing with the day-to-day life and even in a different science. So it might be in agriculture. So when you go to the field, you are doing application of fertilizer and the things. So you are doing something related to chemical changes and food science, toxicology, environmental science, so waste removal. So that is also going on with the chemical changes, geology, mathematics, physics, biomedical science, biology, medicine, so biochemistry, molecular biology, all around the field. So the chemistry is the basic fundamental science. what are the branches of chemistry? So chemistry, there are different branches. Organic chemistry means study of the matter that contains carbon. Basically, the main element is carbon. Other than carbon, hydrogen, oxygen, nitrogen might be there, but organic chemistry is the study of matter which contain element carbon. And inorganic chemistry is the other things, that means without carbon, non-carbon organelle, study that does not contain element carbon. For example, if you are talking about sodium chloride, magnesium sulfate, or and reactions with the water, so whatever the things without carbon, so that is coming under inorganic chemistry, acarbonic rasayan. Carbonic rasayan means if you are talking about the study of matter, maybe study of matter that contains the element carbon, methane, ethane, and so the ethylene, whatever the thing, acetic acid, any compounds which are contain carbon, and if you are talking about their changes or the reactions, that is coming under organic chemistry. Benzene, toluene, those are studying of the matter with the carbon is organic chemistry. And biochemistry is, as I mentioned, bio is life, and the chemical processes, if you're studying the chemical processes in living things, that is biochemistry. Under physical chemistry, we'll study about the mechanism of chemical reactions, rate of reactions, energy changes during the reactions, studied under physical chemistry. So that is important for the optimization of chemical reactions in industrial, especially in industrial purposes. We need to know about the chemical kinetics and the rate of chemical reactions and how to optimize the rate of reactions to get the maximum yield. So therefore, that studying of physical chemistry is also important. And the other one is analytical chemistry. That is another most important one. That is analyze or examine the past or composition in a kind of a food material or maybe in a polluters or whatever the thing. We need to analyze what is the amount of that particular element or a compound is present in that mixture and their percentage and their reactions. So those things, examine or analyzing their compositions, that is coming under analytical chemistry. So then let's start with the matter and its properties. So matter, if I ask what is matter, මොකද්ද පදාර්ථය කියලා අපි අහුවොතින් අපි කියන්නේ matter is anything that occupies space and has a mass and a volume. අවකාශයක් තියෙනවා, ස්කන්ධයක් තියෙනවා, හා පරිමාවක් ගන්න. එහෙම ගන්න ඕනම දෙයක්කට අපි පදාර්ථයක් කියන්න පුළුවන්. මේ ඔක්කොම අපි වටා තියෙන සියලුම දේ පදාර්ථ. So anything that occupies space, අවකාශයක් ගන්න space and has a mass and a volume. So those are matter. Anything that occupies space and has a mass and the volume are considered as matter. So the matter is having a mass, ස්කන්ධයක් තියෙනවා. That is the amount of material that can be measured in an object. Mass and the weight is two different things. අපි ස්කන්ධය හා බර කියලා කතා අපි generally we are talking about as a weight, but incorrect. That is weight, it's depend with the gravitational force. It differ with the gravitational force. So the weight of a person on the moon and the earth is different because of the gravitational force in both in earth and the moon. But mass is not going to be different. It is same in everywhere. Mass can ස්කන්ධ, amount of material that can be measured in an object. ඔයගලන්ට පේනව නේද screen එක?
Yes, ma'am.
Yes, share වෙලානේ තියෙන්නේ. Okay. 1 minute. Then the volume is the amount of space the object occupies. The volume is the amount of space the object occupies. So the matter can be exist in different form, maybe as a solid or a liquid or a gas. So what are the subcategories of matter? So matter can be categorized based on its composition and the properties of matter. So matter can be categorized as a substance or mixtures, elements, compounds, atoms and molecules. ද්‍රව්‍ය හා මිශ්‍ර මූලද්‍රව්‍ය හා සංයෝග හා පරමාණු හා අණු විදිහට අපිට matter එක categorize කරන්න පුළුවන්. So this is the classification of matter. So the matter can be either pure substance, and with the collection of pure substance can form a mixture. So the pure substance can be separated from the mixture by using a physical method. And mixtures can be exist as either homogeneous mixture or heterogeneous mixtures. Samajatiya ha visamajatiya mixture. Pure substance can be exist in the form of compound or elements. And to separate the elements from a compound, we need to have a chemical method. Substance is a form of matter that has a definite, constant composition and distinct properties. යට නියත සංයුතිය තියෙනවා. Constant composition and distinct properties. ඊයටම ආවේනික ගුණාංගයක් තියෙනවා එක්යම්කිසි ද්‍රව්‍ය. If I say water, so we know the properties of water. And the chemical composition is always H2O, 2 hydrogen atoms and 1 oxygen atom. Ammonia, NH3, table sugar, sucrose, gold, oxygen. So those are the substances. They have constant composition and the distinct properties. And they differ from one another in composition and can be identified their appearance, smell, and other properties. So we can differentiate water and ammonia. Likewise, they have a distinct properties where we can differentiate them easily. And when it's the mixture, is the combination of them. Combination of two or more substances form the mixture. Then in the mixture, which those substances retain their distinct identity. So air is a kind of a mixture. Mixture of gases are in air. And milk is a mixture. Sugar solution, sugar with water. So it's a mixture. Salt with water, it's a mixture. Salt solution, cement is a mixture. Soft drinks, carbon dioxide dissolved in water, that is also mixture. But the issue is that they do not have constant composition. So we cannot say if I prepare sugar solution in here and you have prepared sugar solution in your place, so we cannot say both solutions are having same constant composition. So I may have added 2 tablespoons of sugar, but you might have added 3 tablespoons of sugar. So then the composition could be changed, and we cannot say it is having a constant composition. නියත සංයුතියක් තියෙන බව කියන්න බෑ. So the mixtures can be either homogeneous mixtures and the heterogeneous mixtures. So any mixture can be created and separated by physical means into pure components without changing their identity of the components. For example, sugar solution and iron sand mixture. So we'll discuss further with the properties of these mixtures. So please go through these characters of homogeneous and heterogeneous mixture. This is important for your exam point of view. Can't hear කියලා තියෙනවා. So can you hear me? ඇහෙනව නේද මාව?
Yes, madam.
I have already switched on the video also. I think hope you can see him. So if you have anything, please ask. Please tell me, okay? You can switch on the microphone and so please go through these characters of the homogeneous and heterogeneous mixtures. This is important for your exam also. Homogeneous, samajatiya mishranyana, the composition of the mixture is same throughout. If you get the composition from any part of the mixture, that is same. So if I get a sugar solution, so in a particular sugar solution, okay, sugar solution but when you take a particular mixture, sugar dissolved in water. So the composition of the mixture is same throughout when you take in any part of the solution, because sugar is completely dissolved in water. Once you dissolve sugar in water, you cannot separate sugar and water separately. Once you dissolve salt in water, you cannot separate salt and water. You cannot clearly identify. We can separate salt and water by evaporation. But once you dissolve salt in water, you cannot see clearly. So this is salt and this is water. You cannot say once it is dissolved, because salt is completely dissolved in water. But when you get a heterogeneous mixture, the composition of the mixture is not uniform. For example, coconut oil in water. So coconut oil is not going to dissolve in water. Coconut oil will float on the water. So when you get a part of the mixture from the top, you might get more coconut oil than water. But if you get a small part of the mixture from the bottom of the solution, so you will get more water and less oil, or may not have oil. So therefore, you cannot say if you get any part of the mixture, you have a same composition. So we cannot get the composition of the mixture is not uniform in heterogeneous mixtures. And when it's come to the appearance and other physical properties are same or uniform in a small part of the mixture, as I mentioned. So if I get coconut oil in water, so if you get the upper part and the bottom part, their appearance and the smell and everything is different. But in a homogeneous mixture, if you get a salt dissolved in water source solution, if you get any part from top, bottom, middle, or anywhere, so all parts are having same appearance, same physical properties, and is uniform like this. And homogeneous, it considered cannot be separately identified. Once it dissolves, we cannot separately identify. But heterogeneous, we can identify the constituents separately. So if you have coconut oil in water, you can say upper layer is coconut oil, bottom is water. If you mix sand with the iron filling, so this is sand, this is iron filling. So you can separately mention it. But in homogeneous mixture, you can say this is salt, this is water. But you can separate them by physical means. By evaporation, salt and water will be evaporated. And if you want to get the water back, so you can condense the water and you can get it again. But salt, the salt will be retained in the plate. So once you do the evaporation. And coconut oil in water also clearly identifies, and mix with iron also clearly identified. Then the elements and compounds. So the substance can be either element or a compound. Element is a substance, mooladravya කියලා කතා කරනවා, which cannot be decomposed into simpler substance by chemical means. රසායනික ක්‍රමයකින් තවදුරටත් decompose කරන්න බැරි simple substance එකක් බවට පත් කරන්න බැරි දේවල් අපි මූලද්‍රව්‍ය හැටියට ගන්නවා. So far 113 elements have been identified, and most of them are naturally occurring elements and some are synthetic elements. So when we are naming the elements, first letter symbol always capitalized. So, but any following letters are not capitalized letters. For example, for sodium, we say Na. Na indicates the sodium. Even though name is sodium, so the The symbol has been derived from its Latin name, that is natrium. First two letters has been taken, natrium. I will get the pen. So the sodium. So the sodium Na was derived from the first two letters of the natrium, that is the Latin name. And lithium, that is also first two letter Li. Aluminium, first two letters. Silicon, first two letter. Here for carbon, we will take only one letter, carbon, boron, like that. And CO, we have two different COs. So the capital C simple O represent cobalt element, but if you write here C capital O capital, that denotes carbon monoxide, that is a compound. So the element is composed of only one kind of atoms. ඕනම මුලද්‍රව්‍යයක තියෙන්නේ carbon element is having carbon atoms. Oxygen element is having oxygen atom. Oxygen මුලද්‍රව්‍යයේ තියෙන oxygen පරමාණු. So the iron also derived from the Latin name ferrum. Gold was derived from Latin name aura, AU. A substance composed of atoms of two or more elements chemically united in fixed proportions, and unlike mixtures, they form compounds, and compounds can be separated by chemical means into their pure components. So we cannot use the physical means, evaporation or something like that. We need to do a chemical changes to separate the pure components. Hydrogen, oxygen united together, combine together and form water. So we discuss the matter with the mixtures, pure substance, homogeneous, heterogeneous, compound, and the elements. All substance can exist in four different states: solid, liquid, and plasma. Plasma is something a little bit different. Solid, liquid, gas is the one which can be easily identified by ourselves. ඝන, ද්‍රව හා වායු විදිහට තියෙන්න පුළුවන්. So solid is the completely packed. Atoms are completely packed. No any physical the motions movements is very less. We or no, there's no any movements. Liquid is a little bit loosely packed. Gas is the one which is loosely packed, and the distance between molecules or the atoms is very high. Plasma is kind of electrically charged gas. It consists with positive and negative ions. Plasma is a state of matter consisting of free charge particles. 1 minute. So the plasma is a state of matter consisting of free charge particles, lightning, solar wind, aurora. So in the north part of the Earth, we can see that aurora. So the different solar radiation, solar and fluorescent light, nuclear fireballs. So in such cases, the state of matter is plasma, positive and negative charged particles. So the plasma is considered as the fourth state of matter despite solid, liquid and gases. It is one of the fundamental states of matter and technically it is an ionized gas consisting of positive ion and the negative and free electrons. Typically at low pressures as in the upper atmosphere and fluorescent lamps, or at very high temperature as in stars and nuclear fusion reactions. So the plasma should be called as first state of matter because it is what all the states arise from. So when you get the solid, liquid and gases, solid, so the molecules are held together orderly fashion with little freedom of motion. It has a definite shape. Apita solid definite shape and volume. It's rigid and cannot be appreciably compressed. It's difficult for us to compress. Apita compress karanna amaru. But compared to solid, liquid is a little bit compressible. So liquid molecules are held close together but are not held so rigidly in position and can move past one another. It has a distinct volume but independent of its container. But no specific shape. So it assumes the shape of the container and not easily compressible as little free space between particles. But compared to solid, it is a little bit compressible. So easily we can compress gases. So the gas molecules are separated by distances that are large. Compare the size of the molecule. No fixed polymerase shape. It conforms to the volume and shape of its container and can be compressed or expanded to occupy different volumes. Plasma is a hot ionized gas consisting approximately equal number of positively charged ion and negative charged electron. So those three states of matter, solid, liquid, gas, we can interconvert it without changing the composition of the substance. So very good example for the interchange of the state of matter is with water. So the water can be exist in liquid, solid, that is ice, gas, that is steam, or water vapor. So by evaporation, you can make it liquid water into a gaseous state. By by freezing, you can make the water into a solid form, that is ice. So ice can be again converted to water by melting. And the gas can be converted to liquid again by condensation. So therefore, we can do the interconversion of the states of matter. So then there are 2 points we can recognize, melting point and the boiling point. So the melting point is the one where the temperature at which solid becomes liquid. And boiling point is the one which is where liquid become a gas. The temperature at which liquid become gas is the boiling point. And melting point is the one solid become a liquid. So the melting point of ice and the freezing point of the water exactly the same temperature, that is 0 degrees centigrade. So the melting point is when solid is changed into liquid. Freezing point is when liquid is changed into solid. And in the conversion of the matter, 3 state of matter, you can see the summary, and even solid can be directly converted to gas and gas can be directly converted to solid by solidification. Solid can be converted to gas by sublimation. Solid direct can make it as a gas as well. And physical and chemical properties of matter. So physical properties can be measured and observed without changing the composition or identity of the substance. For example, appearance, melting point, ability to conduct heat and electricity, state of the matter, density. So we can observe them or measure them without changing their composition. But when we are talking about the chemical properties of the matter, in order to observe those, whether the combustible, the honey we hacky the nectar, whether it can react with the acid and what would be the result of the reaction with acid. On high heating can form one or more new substance. So in order to do so, we have to do the changes. So this under that condition, substance may undergo chemical change and their compositions and other things could be varied or changed. Again, all these measurable properties of matter can be divided into two categories that are extensive properties and intensive properties. Extensive means those properties are can be added together. I mean the properties that depend on how much matter is being considered. And values of the same extensive property can be added together. For example, mass, length, volume are considered as extensive properties. If I say if I'm going to mix 5 gram of sugar with another 10 gram of sugar, like this. If I mix 5 gram of sugar with 10 gram of sugar. Now, you know, all together in that basket, you have 15 gram of sugar. If I join 2 meters with another 2 meters, so finally you have 4 meters. That means, so those values of the same extensive property can be added together. It has a meaning of that. So it depends on how much matter is being considered. So the more mass means it represents more matter is. More length indicate more is there. Length is increasing. So, but when you come to the intensive properties, they does not depend on how much matter being considered. Once I explain it, you could understand the difference between extensive and intensive properties. Like this. Does not depend on how much matter is being considered. They are not additive. For example, temperature. Let me explain one example. So if I mix 50 degrees Celsius water, now you have one beaker with the temperature is 50 degrees Celsius, and you mixed it another beaker having same temperature, that is 50 degrees Celsius. So if it is an extensive property, these two should be additive. And finally, so your water should become 100 degrees Celsius. Make additive effect එකක් නම් extensive property එකක් නම් 50 වෙනවා. But you know that even though you have mixed with 50 degrees Celsius water, with another 50 degrees Celsius water, you won't get 100 degrees Celsius water. Again, in that third beaker also, you are having 50 degrees Celsius, same temperature. Therefore, intensive properties are not additive. They do not depend on how much matter is being considered. Even though the water volume has been increased, the volume is additive. The volume is extensive property, but mass has been increased, but the temperature of that matter or the property, that temperature is not additive. ඔයගලන්ට පැහැදිලි වෙන්නේ නැති කියලා මට හිතෙනවා. Extensive or intensive, this is also important in your exam point of view. Please keep in mind what are the properties coming under extensive property category and what are the different properties which are coming under intensive property category. So the mass, length, the volume, those are considered as extensive properties. Easily you could understand whether it is intensive or extensive. Think about the same property values, whether they can be added together or not. ඒකෙන් ඔයගලන්ට ලේසියෙන්ම හොයාගන්න පුළුවන් මේක extensive ද intensive property එකක්ද කියලා. Even for the concentrations, so the concentration also won't change how much matter being considered. Physical and chemical changes. So the physical changes are and the physical and chemical properties are not going to be altered. The boiling of water, still H2O is there even though you are boiling of water. But under chemical changes, so if you ferment the sugar, so finally you will end up with another two different compounds as alcohol and carbon dioxide, and ultimately you don't have sugar. Therefore, the composition of the substance are changed under chemical changes, and the chemical bonds in the molecules are broken, rearranged, and new substances are formed. So that's all about the matter and its properties. If you have any questions, you can ask. So under matter and its properties, so please try to understand the so under matter and its properties, so please keep in mind homogeneous, heterogeneous mixtures. What are the differences between them? An example for them. And extensive and intensive properties, and what are the four different states of matter, and to differentiate them. Boiling point, melting point, those things are important under this chapter. Then second, we'll go to the next chapter. Let me share it. Then units and measurements. And the units and measurements. So being an experimental science, chemistry involves measurements. So we have different instruments and glassware to get the correct, accurate measurements. So we can use meter sticks for the measurement of length or a scale, and burette we have in glassware to measure the volume. We have different glassware, burette, pipette, graduated cylinder, volumetric glass, like that. And to measure the mass, we have balances, analytical balance. This is what is seen in this slide is analytical balance. So you can measure very small quantities accurately. And the top load imbalance. And we have thermometers for the measurement of temperature. So likewise, we have different instruments and glasswares to take the measurements accurately. So when you are getting a measurement, so accuracy of the measurement depends on the the instrument or the glassware that you are using. So for example, when you are measuring a volume, you can measure the volume using a measuring cylinder, using a burette, and using a pipette. So measuring cylinder, minusara, it's not much accurate one. It hold either 100 or 250 cubic centimeter or millimeter, or one more than that. So you can have different volume. Measuring cylinders are available with a different 10 milliliter and 10, 150. Likewise, you can have different volume measuring cylinders. Their accuracy is up to 1 milliliter. 1 milliliter accuracy is up to 1 milliliter. But when you're getting a burette, so in your titration, so once you come to the practical, so you are dealing with this burette. So it can, a maximum volume that can hold is 50 milliliters, but the accuracy is nearest 0.1 milliliter. And when you're getting a volume, if you need to have a fixed volume to uptake, so you will use the pipette. So you will use that glass pipette in your titration practical. So 25 milliliters, 50 milliliters, likewise, there are different volume pipettes. And if you want to get exactly 25 milliliters, so you better go for a pipette and you can uptake 25 ml. So you can see here there is a mark. So up to that mark, you have to suck the volume to this pipette. So then it will use the 25 milliliters. අපි මිලිලීටර් 25ක් හරියට මෙෂර් කරගන්න ඕනේ නේ. පිපෙට් එකකට තමයි ලැබ් එක යූස් කරන්නේ, ග්ලාස් පිපෙට් එක. එතකොට ඒකේ අපි 25 50 වගේ තියෙනවා 10 25 50. So nowadays we have graduated pipettes as well. In that case you can have some varying amounts, but this kind of pipette, if this is not a graduated pipette, so if it is defined as 25 milliliters, you can get exactly only 25 ml, but it is highly accurate fixed volume. Rather than measuring 25 ml using a measuring cylinder, if you are going to do a titration, because in a titration, the getting of exact volumes is highly important. Otherwise, your final answer would be wrong. So it would be incorrect. So therefore, to get the exact measurements, you will use pipette to get the exact volume of the solution. And the other solution is held in a burette. So I will explain them later in the last chapter. So you can see the ranges of measuring cylinders are there. So when you are getting the measurements also, then it is important to note that. So you have to go to this meniscus. So you can see this curvature like this meniscus. So you have to read the bottom of the meniscus. Sorry. It should be in your eye level. Likewise. So I can't make it. You have to get the measurements with your eye level. So you could see here bottom of the meniscus. This is the what? Sorry. So your eye level should be there with the in line with the bottom of the meniscus, and that is the point you have to get the reading. So otherwise the reading will be wrong. So you cannot go read it as from top or bottom. The bottom of the meniscus should be in line with your eye level. Then you have to get the reading. So even in a measuring cylinder burette, so you have to check whether what is the place where the meniscus touching with the scale. කොතනද මේ bottom of the meniscus එකේ යට කොතනද touch වෙන්නේ කියලා අන්න එතන තමයි අපි ඇත්තටම read කරන්නේ. එතනින් තමයි reading එක ගන්න. If you get the reading from the top, here is wrong. So you have to have your eye level in line with the bottom of the meniscus. So here the titration setup you can see. So we will hold the pipette over there. So this is your pipette. And this is the conical glass. So the pipette, sorry, this is the burette and this is the conical glass. So you want a solution is in a conical glass. The solution to be measured, the concentration is unknown, and non-concentration solution is in burette. So we'll add the non-concentration solution dropwise into the into this glass, conical glass. For this plus, we'll get the known quantity of the solution, that is by using pipette. So this is having fixed volume. This is the graduated pipette. So here you can have a varying amount, but here you can get fixed amount. So these instruments provide measurements of macroscopic properties which can determine directly. Microscopic properties on the atomic or molecular scale must be determined by an indirect method. A measured quantity is usually written as a number with appropriate unit. So in any measurements, we have two things, accuracy and the precision. If both are there, then only we can have a reliable measurements. What is the difference between accuracy and the precision? Accuracy means the closeness of the observed measurements to the true value of the quantity. So usually when you are getting measurement, when you are doing a titrations, usually we'll get 3 measurements. If you are doing a titration, we'll get the 3 times. We are repeating the same thing 3 times and get the average later. So once you get the 3 measurements, once you repeat the experiment 3 times, now you will get 3 data. You have 3 measurements of volume if it is a titration. If you have these 3 different measurements, if they are totally different to each other, that means there's no precision at all. The precision refers to the closeness of the set of data to the closeness of the set of data obtained from identical measurement of a quantity. That is the closeness of the set of data. For example, in this figure, you can see here, if I say the accuracy is the middle center, the true value is in the middle. අපි කියමුකෝ true value එක තියෙන middle එකේ කියලා. If I say the true value is in the middle, සත්‍ය අපි expect කරන volume එක, expected measurement එක තියෙන center කියලා. So now we have got the 4 measurement of a particular set of data. If it is a volume, 4 volumes might be have taken. In the first figure, you can see all four dots, all four measurements are close to each other. That means you have precision in your data set. Precision එකක් තියෙනවා. ඒ data හතරම එක සමානයි. එක ළඟ තියෙන. ඒතර precision එකක් තියෙනවා. And same time, all four data are close to the true value of the quantity. What is the volume that you are expected? So that is close to the true value. Therefore, accuracy is also there. So this measurement is having 100% accuracy and 100% precision. When you go to the second figure, true value is somewhere in here, that is middle. And your measurements, four measurements are far from that value. That means your measurements are not accurate. Ek accurate nahi. But once you repeat the experiment, those 4 times you have got the data which are close to each other. So that means you might have taken initial volumes or whatever the quantity you have measured might be wrong, but you have performed the experiment correctly and you have got the data based on that. But as you have measured or weighed wrong quantities, you are far from the true value, but you have performed the experiment correctly. Therefore, you got the precise data. The closeness of your set of data is there, but you are far from the accurate value. Therefore, you don't have accuracy in there, but you have precision over there. And here you can see the 4 set of data are different from each other. And also they are, anyhow, even though they are different from each other, they have kind of a closeness to the true value. Your 4 data don't have a precision. 4 times you have repeated, but you don't have a precision, but you have not 100% accuracy, but have a little bit more accurate. And the other one, the fourth one, you can say you don't have any precision or you don't have even accuracy. So that's the difference between accuracy and precision. So please try to understand the difference between those two. So the SI units are the ones. So 1960, the General Conference of the Weight and Measures, the International Authority, units proposed, International Authority on Unit proposed reverse metric system called International System of Units. So those are known as SI system, and there are 7 SI based units. And all other units are derived from the 7 SI based units. These are the 7 SI based units. So for the exam point of view, please keep in mind those 7 SI based unit and the unit, what is the unit going to be measured, those base quantity and their symbols. Okay, this is important. Base quantity, length, mass, time, temperature, electric current, luminous intensity, and the amount of substance. Length measured by the international unit is the meter. The SI base unit is meter, not the any other unit. Okay, centimeter, millimeter, kilometers නෙමෙයි ගන්න. අපි meter තමයි ගන්නෙ SI unit එක හැටියට. Mass is measured with the kilogram, time, second, temperature, Kelvin, not the Celsius or Fahrenheit, Kelvin temperature, නිරපේක්ෂ උෂ්ණත්වය, Kelvin. Electric current, ampere, luminous intensity, අපි කියන්නේ දීප්ත තීව්‍රතාවය, candela, and amount of substance is mole. So the symbols are meter, simple M, mass, simple kg, time, simple S, temperature, capital K, electric current, capital A, luminous intensity, simple CT, amount of substance, simple MOL. These are the symbols of 7 SI based unit. If I say volume, can you give me the unit of the volume? Volume is a derived unit of the SI base unit. SI base unit වලින් derived වෙච්ච එකක් තමයි volume කියන්නේ. පරිමාව. If you know, can you please give me the unit for the volume? Can you derive the unit for the volume? You can put into the chat box. Volume පරිමාව කියන්නේ මොකක්ද? පරිමාවේ unit එක දෙන්න බලන්න. Not in case of liters, so please give it me in the form of SI base unit. Okay, others? Very good. Others? දෙන්නයි තාමද. කම්මැලිකම යන්නත් එක්ක ටක් ගාලා කරන්න. So keep in mind what is the symbol. So the meter is the simple length. So you have to denote the symbol with a simple M, not the capital M. Okay, very good. You all have understood. So not the milliliter, okay, because SI base unit, now the volume should be derived from the length. So the volume is length into height into width. So all three are kind of a length measurements. දිග පළල උස නේ අපි ගන්න. So the length, the SI base unit is meter. Okay. So the length, SI base unit is meter. So the length, now meter into meter into meter. So that is cubic meter. M to the power of 3. So this is the derived unit for the volume. So this was derived from the length. The volume, the derived unit symbol is meter, cubic meter. So this was derived from the length. Okay, that's what I want to tell you. Okay, good. So the SI unit system is based on the decimal system. So the SI prefixes are used to express large and small quantities than SI base unit. Prefix indicate power of 10. For example, let's take this one. So the meter is the SI base unit. So the meter, the quantities which are larger than that. So likewise, kilometer, megameter, gigameter, tetrameter. So the 10 to the power 3, 10 to the power 6, 10 to the power 9, 10 to the power 12, like it's going on. The higher values. Low values than the meter is decimeter. 10, you have to multiply it by 10 to the power minus 1 or 0.1 meter equal to 0.1 meter. Centimeter and the millimeter, micrometer, nanometer, and picometer. So the nano is always 10 to the power minus 9. Micro, 10 to the power minus 6. Nano, 10 to the power minus 9. Pico is also 10 to the power 12. So the prefix is this one, tetra, giga, mega, kilo. And the lower values, deci, centi, milli, micro, nano, pico, likewise. So the meter, you can convert a kilometer into the meter by multiplied by 10 to the power 3. You can convert centimeter into the meter by multiplying with 10 to the power minus 2. Here you can see, clearly understand, meter is the SI base unit. So the upper values and the lower values, how you can convert the units to upper or lower values. So that's what I asked you to do, the volume, area, density, force, pressure, energy. Those are coming from the derived SI base unit. So area is square meter and the volume is with the cubic meter and the density is kilograms per cubic meter. Okay, Ganatva density. And the force is the බලය අපි කියන force is with the Newton and you can derive it with the SI base unit as well using the equation force equals mass into acceleration, pressure and the energy likewise. So that we have denoted SI symbol as the Pascal and the Joule for the energy, but you can have the derived unit from the SI base unit. Same here, density, you can see area, length into length, volume, length, 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 and the density mass divided by volume. ඒකක පරිමාවක ස්කන්ධය තමයි අපි density කියන්නේ, the mass of a mass per unit volume, and the velocity, displacement, time. So I'm not going to ask in your examination in detail those things, but you could have idea. Those quantities are derived from the SI base unit, and we have only 7 SI base units. So the non-SI liter, milliliters, those are non-SI units. Pressure we can measure with the atmosphere, and temperature, Celsius, Fahrenheit, energy, calorie, likewise, those are not the SI base unit. So the time is the only SI base unit which deviates from the decimal system because it does not have a power of 10 conversions. So 1 minute equal to 10 seconds. Likewise, it does not have a decimal system. As I mentioned earlier, mass and weight are two different things, and mass is a constant. It does not depend on the gravitational force, but the weight depends on the gravitational force. So if you measure the weight of a person on the moon and on the earth, so that depends on the gravitational force. So your mass should be multiplied by the gravitational force of the respective place. But mass is always same. So if it is 56 kilogram, even though you are in a moon or a earth or a Jupiter, whatever the place, your mass is 56 kilogram. So the chemists are interested primarily in mass, which can be determined readily with the balance. But process of measuring mass, oddly speaking, we say it's weight, but that is not weighing. So you are getting the mass, but we just for when we are speaking, we tell it as weight, and we are asking you to get a weight like that. The volume, so cubic centimeter, so you can get, please keep it in mind, cubic centimeter is equal to cubic milliliters, and cubic decimeter is equal to liters. Density also is SI base mass divided by volume, so you can go with the grams per milliliter, or you can, if it is a gas, you can go for a grams per liter. Temperature, then it is very important. We have 3 different scales of temperature: Fahrenheit, Celsius, and the Kelvin. So we know that Fahrenheit, the freezing point of water, we know the Celsius is 0 degrees centigrade, but it's in Fahrenheit, it is equal to 32 degrees Fahrenheit. Boiling point is with 100 degrees centigrade equal to 212 Fahrenheit. So when you get this, and in case of Kelvin is different from the Fahrenheit and Celsius scale. So this is the SI base unit of the temperature, and this is said to be absolute temperature scale, nirapeksh ushnanta. And 0 on this scale, or 0 Kelvin, is the lowest possible temperature that can be attained theoretically. Theoretically, යන්න පුළුවන් lowest temperature එක හැටියට අපි දකින්නේ 0 Kelvin. So that is known as absolute 0. And 0 Kelvin is equal to, 0 Kelvin is equal to, here you can see, sorry, minus 273.15 degrees centigrade. Okay. 0 Kelvin equals to Celsius minus 273.15 degrees centigrade. So the 0 Kelvin is the one which is theoretically, the lowest possible temperature that can be attained theoretically. And the other important thing is that when we are denoting the Celsius and Fahrenheit, we denote it with the degree sign, degree Celsius, degree Fahrenheit. But with the Kelvin, we don't have degree sign. It's not a relative value, it's an absolute measurement. So we don't have degree sign over here. Okay. So temperature in Kelvin scale does not use degree sign because it is an absolute scale, not a relative scale. So you should know the interconversion of Celsius, Kelvin, and Fahrenheit. So the Kelvin to the Celsius, so it's easy to convert Kelvin to Celsius. So for the particular Celsius temperature, you have to add 273.15. Then you can convert that temperature to the Kelvin. So both the Celsius and Kelvin scales have units of equal magnitude. That is 1 degree of Celsius is equivalent to 1 Kelvin. And experiment studies have shown that absolute zero on the Kelvin scale is equal to minus 273 degrees Celsius on the Celsius scale. 273.15. Therefore, you can easily convert to Celsius because equal scaling is equal 100 parts, here also 100 parts, and therefore you just want to add the 273.15 to particular Celsius temperature, then you can get the Kelvin temperature. And when you get the Fahrenheit and Celsius, so when you get the lowest fixed point as the freezing point, highest point as the boiling point, in between those 2 points, Fahrenheit is having 180 sections. But between freezing and boiling point, Celsius scale is having 100 sections. So the 100 section of Celsius is equal to 180 sections of the Fahrenheit. Based on that, we can derive an equation to convert Celsius and Fahrenheit. So to convert Fahrenheit to Celsius, you have to deduct 32 degrees Fahrenheit from a particular Fahrenheit temperature and multiply it with 5/9. To convert Celsius to Fahrenheit, the particular Celsius temperature, you should multiply it by 9/5 and plus 32, and then you would get Fahrenheit scale. So that is the summary. So you can do it quickly. So this is also important. You can get calculations. Sorry. So I have given 3 review questions from your module. I have taken these 3 review questions. So quickly, can you go through? I have given the equation here. But for your examination, we are not going to give these equations. So you should know the way that you have to convert Celsius, Fahrenheit, and Kelvin likewise. Quickly give me the answers in the chat box. It's really important for you to practice the review question while I'm doing this lecture. Then it would be easy for you for your examination point of view. Okay? මේ අනගම මේක කරන්න time එක චුට්ටක් විනාඩියක් දෙකක් අරන් කරන්න බලන්න. So then it would be easy for you to exam. So please go through the questions that I have given in the lecture notes as well. Okay? මේක දීලා තියෙන්නේ මම අතනින් ගත්ත ඒවා extract කරගත්ත ප්‍රශ්න. අනිවාර්යෙන් first of all you have to follow all these questions that I have given in these lecture notes, and then you can practice the rest of the thing. එහෙම කරොත් then the exam is nothing for you. අග්ගාල හදලා දාන්න බලන්න. So I can say only few of you are giving the answers, but if you are getting this chance and if you are giving the answers in right at the moment, so then it would be easy for you to pass the examination. ටගාලා හදලා දාන්න. A, B, C. Mhm. B. A, okay. Only two of you have given the answers. Only two of you are giving the answers. I don't know what happened to the others. Yes. Okay. Very good. So, Salinda, Kaushi, Ramanayako, only three of you are giving answers. Very good. I don't know what others. If you get this chance, you won't be in a trouble in the exam. Otherwise, you won't get any time to practice there. මේ දැම්ම මේ වෙලාවේ කරලා ප්‍රැක්ටිස් කරනවා මිසක් ඔයගලන්ට ආයි ටයිම් එකක් දෙයි කියලා හිතන්න එපා මේක කරන්න. So that is why I am giving a little bit chance for you to at least practice and give the answers. ඒතර මේ වගේ එකක් කරා කියලා මෙහෙම කරා කියලාවත් මතක් වෙනවා ඔයගලන්ට. ආයි ඔයගලන්ට මේක ස්ටඩි කරන්න වෙනම වෙලාවක් එයි කියලා හිතන්න අමාරුයි. Okay, very good. Those who are doing that one. So I will share the answers. The first one, 620.6 degrees Fahrenheit. B, 77.78 degrees Celsius. And third one, minus 196.15 degrees Celsius. So those are the answers. So please write the correct units and check whether the sign of the one. So here the C, especially the Kelvin temperature is converted into Celsius. Now it's become minus 196.15 degrees Celsius. So those are the answers for your MCQ paper. So you will definitely get this kind of question. So that's all about the first part of the units and measurements. So then let me go through. So we will get the break. අපි මේකත් ඉවර කළාම break එකක් ගමු. We'll have a short break. Not right now. So let's complete this part. Okay, handling numbers. So the scientific notation is the representation of a number in the form of n into 10 to the power simple n. So the capital N denotes the number in between 1 and 10, and the simple n is a positive or negative integer. Integer means whole number. So the capital N is kind of, we say, to be coefficient, and the 10 is the base. The පාදයක් විදිහට අපි දෙන්නේ 5 is the exponent. So the scientific notation is important when you are going to represent a large values, maybe very less or large, 0.000 something like that, or the 100,000 something like that. If you are going to represent a large or small quantities, so then you might get in a trouble. So you might be having a kind of a mistakes, errors could be happen. But if you can represent them with a scientific notation, it would be very convenient, and you can denote your numbers or measurements with the correct significant figures. So any number expressed in this way is said to be scientific notation. So for example, in here, 568.762, so we can represent with the scientific notation. So the n should be in between 1 and 10. So for that, what we are doing, let me get the pen. Okay. So the 5 in capital N එක හා 10 අතර වෙන්න ඕනේ. So what you have to do is, so we count how many digits that you have to move in order to place the decimal point. So here you have to move so the 6, from here you have to place the 6 point, the decimals. For that you have to move 6 and 8 over here, and then you can get 5.68762. Since you have moved 2 decimal places, now 10 to the power 2. Likewise, in this case also you have to 0.001. So in order to place the decimal, get the capital N and 1 and 10 between, so you have to count how many decimal places that you have to move. Then how do you determine the, whether it is positive or negative integer, the simple n. Let me discuss. So the usually n equals 0 is used for the numbers that are not expressed in scientific notation. So 10 to the power 0 is, we are not going to represent as in that way. Usually omit the superscript when n equal 1 as well. So this is the way that we are correctly writing the scientific notation. First of all, you have to move the decimal place at the left or right as needed to give the number in between 1 and 10. As in early example, 568.762. Here what we have to do, you have to move the decimal point to the left. So you have to move 2 digits for the left, then 5.68762 is coming. Since you have moved 2 digits, so the power is 10 to the power 2. And the sign of the simple n, so if you are moving to the left, it is positive. If you are moving that point decimal to the right, then the sign of the simple n is negative. So here, since you have moved to the left, so your sign of the simple n is positive. And here 3,960,000. So in order to get the capital N in between 1 and 10, you have to move. Here we are assume that decimal point is here, and after that zeros are here. Okay. So now your decimal point should be moved to 1, 2, 3, 4, 5, 6. Then only you can have a decimal point here. That is 3.96. Now we are not going to represent these zeros. Now altogether they are in here. Okay. So no, we are not going to write again these zeros. Now we have a value 3.96 and altogether now it's in here 10 to the power 6. If you want to explain again to this one, what you want to do is you have to multiply 3.96 with 10 to the power 6. අපි මේ බින්දුව ටික දාන්නේ නැහැ. මේ බින්දුව වලින් වෙන වැරද්ද නැති කරන්න තමයි අපි මේක power එකක් විදිහට represent කරන්නේ. Okay then. So here you can see another example. So now the decimal points you have to move to the right side 0.00, 0.00706. Now you have to move this decimal point 1, 2, 3 in here. 3 places you have to move. The answer, the 7.06, that is capital N, and then 10 to the power simple n. So simple n would be the number of places that you have moved, 3 places. As you move the decimal point to the right side, now the sign is negative. 7.06 into 10 to the power minus 3. So that is how we are representing the scientific notations.
Excuse me, ma'am.
Yeah, I have muted one. Okay, sorry. So then, okay. So let's do certain examples. Okay, you can please try these 2 examples. So please quickly give the answer into the chat box. Let's see whether you have understood the section. Quickly, you can get it 2 minutes. Represent these 2. This is from your review questions section. I have taken these 2 questions from the 5th section. Please give the answer in a scientific notation. The first one, 0.00. Second one. Good. Others? මෙතන දැන් ඉන්නේ හැමෝගෙම දෙන්නයි තුන් දෙනයි උත්තර දෙන්නේ. 72 participants are there. This is nothing, so you can quickly give the answer. So then I'm also having a kind of a confidence that you have understood the section, otherwise no point of going beyond that. So if you can't understand anything, please ask me to repeat it again. That is no problem. Okay. So those who are giving the answers, really happy they have understood the sections. Very good. Okay, very good. All are correct. So I will share the answers right now. So the first one, 3.849 into 10 to the power minus 8. So because you are moving your decimal to the right hand side, you have to move 8 places. To move the decimal point, you have to move to the 8 places in order to get the capital N in between 1 and 10. So therefore, the power is 8. Sign is negative or minus because you have moving your decimal point to the right hand side. Second one, that is 4.7764 into 10 to the power 4. As you are moving your decimal, so we expect your decimal is here. Something 00 should be after that. And you are moving to this side. 1, 2, 3, 4. Therefore, 4.7764 into 10 to the power 4. Very good. So then next important thing is the significant figures. What are the significant figures? What are the significant figures? So that means in any measurement or measured quantities carries uncertainty in the last digit. Therefore, it is important to indicate margin of error in a measurement by clearly indicating the number of significant figures. Significant figures are meaningful digits in a measured or calculated quantity that include all certain digits plus a final digit having some uncertainty. Those are the meaningful digits in a measured or calculated quantity that include all certain digit plus a final digit having some uncertainty. So, however, all the digits in the number, including the uncertain digits, are significant. So in a measured quantity, if you get a burette reading is 23.14 milliliters, now we can say this measurement is having 4 significant figures. මේ අංක හතරෙම මේ importance එකක් තියෙනවා, value එකක් තියෙනවා. So how we can determine whether any kind of a digit is a significant figure or not? So we have a kind of a guideline to follow that. First of all, any digit that is not 0 is significant. For any measured quantity, if you have any digit that is not 0, they are significant. For example, 478 is having 3 significant figures. 523.61 is having 5 significant figures. They are meaningful digits. Then the zeros between non-zero digits are significant. If you are writing 1.063, that 0 is a significant figure. So it indicates, it gives value to the measurements. So therefore, there are 4 significant figures. 2.08 is having 3 significant figures. However, zeros to the left of the first non-zero digit. First non-zero, zeros to the first non-zero digits. 0 left of the first non-zero digits are not significant. Those zeros are just here to place the purpose is to indicate the placement of the decimal point. So we do not get them as a value or meaningful digits. but therefore you have only 3 significant figures in here. 0.09, you have only 1 significant figure. So the zeros which are left of the first non-zero digits are not significant. Then, if a number is greater than 1, and then all the zeros written to the right of the decimal point is counted as a significant point. If I say 58.00, that indicates after 2 decimal points, the value is 0, 0, not the 0, 1, or 1, 1, or not that. 58 දශම බිංදුවයි බිංදුවයි. දශම ස්ථානය දෙකකට යනකම් අපිට pretty sure එතන 0, 0 තමයි. Therefore, there is a value of those zeros. Okay, therefore we have to take them into account, and therefore 58.00 is having 4 significant figures. And the 3.040, here the 0 in between non-zero digits are significant, and also right to the this number non-zero digit also significant. Therefore, there are 4 significant figures. So the number is greater than 1, and all the zeros written to the right of the decimal point also considered as significant figures. But if a number is less than 1, and then only the zeros that are at the end of the number and zeros that are between non-zero digits are significant. So we are not getting the zeros in front of the non-zero digit. So those are not significant figures. These are not significant figures, but these are significant. They're here 2 significant. Here zeros in between non-zero digits are significant. 0 right to the decimal point are significant after the non-zero digit. I mean, here the zeros right to the decimal point are at the end of the value, but not the in front of the non-zero digit. Non-zero digit එකට ඉස්සරහ තියෙන බිංදුව අපි ගණන් ගන්නේ නැහැ. නමුත් non-zero digits දෙකක් අතර තියෙන බිංදුව හරි ඊට පස්සේ තියෙන බිංදුව හරි අපි consider කරමු. Therefore, please keep it in mind. So that is how we are going to consider them as whether they are significant figures or not. So if any number that do not contain decimal point, but you have given 9,400 centimeters, and so do not contain decimal point, these trailing zeros, the terminal zeros after the last non-zero digit may or may not be significant. So we can easily understood with that by expressing the value with the scientific notation. If you are giving the scientific notation with this way, I mean 9.4 into 10 to the power 3, then we can say there are 2 significant figures. If I say 9.40 into 10 to the power 3, then there are 3 significant. So you are giving that up to 2 decimal, that is 0. And 9.400 into 10 to the power 3, then 4 significant figures. So according to the way that you are going to represent it in scientific notation, then only you can give the significant figures. The uncertainty can be removed by expressing the number in scientific notation, and the significant figures in the first component should be taken as the significant figures of the number. So this is the summary of that. Zeros in between non-zero digits, and after that will be significant at the end of the number to the right of the decimal point. But zeros which are in front of the first non-zero digits are not significant. And the other important thing that when we are representing the values is the rounding off. This is general theory of rounding off. That is, if the leftmost digit to be dropped is greater than 5 or 5 followed by non-zeros, then we can add 1 to the last digit to be retained. For example, 1.21, if you are going to rounding off to the 3 significant figures, 1, 2, 3, then the value that going to be dropped is 5, and you have 5 followed by non-zeros, therefore you can add 1. Here, the value that you are going to drop is 6, greater than 5, easily you can add 1. But if the leftmost digit to be dropped is less than 5, so you are not going to add 1. To the first, simply drop it and all the digits further to the right. If the leftmost digit to be dropped is 5 or 5 followed by zeros, then you have to think about the value that going to be written, the last digit to be written is even or odd. ඉරටද ඔත්තද අන්තිමට ඉතුරු වෙන ගාන දැන් මෙතන. So 1.225 is going to rounding off to 3 significant figures. So 3 significant figures means cutoff point is from here. Now the value that going to be dropped is 5, and there's no any other value, and 5 followed by zeros. Here it is zeros. So how you determine whether to add 1 to the last digit? If it is even, you are not going to add 1 to the last digit. If it is odd, then you can add 1 to the last digit. Here you can see that is the last digit going to be written is odd, then you can add 1. So this is general theory of rounding off. So I will give you a value for you all, then please tell me whether it is significant or not. Okay. So tell me whether how many significant figures are there? 0.00008, 408. Second one, 4.708. So please give me how many significant figures are there into these two numbers. Please give your answer in a chat box. A and B. Take this one as A. This is B. Quickly, you can put your answer over here. Put into the chat box. Mhm. Yes, good. Others? Yes. Okay, very good. You got the idea. So the first one, you are not going to consider about the non-zero, I mean the zeros in front of the last non-zero digit. So we omit this. Therefore, you have only three significant figures and zero in between non-zero digit will be considered. And the second one, this is 1, 2, 3, 0 in between non-zero digits are significant and 0 right to the decimal place, that is also significant in here. So therefore altogether 1, 2, 3, 4, 5, 6. 3 and 6. Very good. So before doing an atomic structure, so we can have a short break. So we can meet again 12 o'clock. Is it okay for you all? අපි short break එකක් අරන් යමුද? So we can meet again at 12 o'clock, okay? So then we can have a late lunch. Then short break එකක් ගන්න 12 ඉඳන් then we can conduct up to maybe 1:30 වෙනකන් ගිහිල්ලා then after that we can have a lunch again. So please come back by 12. Okay. Keep with the same session. I mean the same link. Okay. Please do not log out. Okay. So you can after lunch you can log with the second link. But for this session, please here still in the first session. Okay. Okay. Atoms and atomic structure. So I don't know why others are not joined. Still not joined. Could you please ask others to join with the same link? Okay. If they have any trouble, please let me know. Atoms and atomic structure. So the timeline. So I hope you can see the screen right now. So the atoms අපි පරමාණු ගැන කතා කරනකොට, so the John Dalton is the one who has explained the one. I hope now you can see the screen. Okay. If you have any issues, please let me know. So the John Dalton is the scientist who put forward the atomic theory. So he explained 4 things related to that. He mentioned that all matter is composed extremely small particles called atoms, and actually he thought that that cannot be further divided into small units. So at that time, they believe that atom is the one which is the smallest unit of the matter. So then all atoms of a given element are identical, having same size, mass, and other chemical properties. And atoms of different element are different from all other elements. That is okay. Carbon is having carbon atoms, oxygen is having oxygen atom, nitrogen is having nitrogen atoms. Oxygen does not have carbon atoms. Likewise, particular element is having the same type of atoms for that element. They are having same size, mass, and chemical properties. And compounds are a combination of those atoms. So the compounds are composed of atoms more than one element. H2O is with a hydrogen, 2 hydrogen, and oxygen. 2 hydrogen atoms combine with 1 oxygen atom. So in any compound, the ratio of the number of atoms of any 2 of the element present is either an integer or simple fraction. So H2O, the ratio of hydrogen to oxygen is 2:1. So the simple ratio is there. And the fourth one that he expressed is a chemical reaction involves only the separation, combination, or rearrangement of atoms. It does not result in their creation or destruction. So atoms cannot be a newly formed or destruction, only happening during chemical reaction, either separation, rearrangement or combination of these atoms could be happen. If I explain this one further, related to third one, compounds, wait a minute. So the compounds are formed by atoms of more than one element. So for example, is the water. Atom in any compound, the number of atoms of any two of the elements present is either an integer or simple fraction. You can see one oxygen atom, two hydrogen atom. Water always contain equal part of hydrogen and oxygen. Atoms of different elements combining fixed whole number ratio when forming compound. If I say CO2, carbon dioxide, one carbon atom with two oxygen atoms. Ammonia, NH3, one nitrogen, three hydrogen atoms. Likewise, they are combined as a whole number ratio. So the atoms are either atoms are neither created or destroyed during physical or chemical processes. There's no any creation of atoms and there's no any destruction of atoms. For example, now you can see methane, CH4, react with oxygen and form carbon dioxide and water. So the one molecule of methane react with two molecules of oxygen and form one carbon dioxide molecule with two molecules of water. Here you can see now the reactant sides. This side is always reactant, pratikriyaka, and this side is having product. Okay. So the reactant side, you have how many carbons are there? Only one carbon. The ash color one is represent carbon. So one carbon atom, four hydrogen atoms, and four oxygen atoms. Are there any changes to them in the right-hand side? That is the product side? No. You can see still the one carbon is there and the one carbon is there and four hydrogen is still there. Let's see. So carbon still there. Oxygen is still there. These are oxygen atoms. These are four oxygens are there. No loss of oxygen. All four hydrogens are still there. But they are in a different form right now. Not as methane. Now hydrogens are in the water molecules. Oxygens are in carbon dioxide and molecules, and the rearrangement has happened. But there's no any destruction or the creation of atoms in the chemical process. So that was the fourth theory that he has explained. The structure of the atom, then after the Dalton theory, it was considered that atom is the basic unit of an element that can enter into a chemical combination. But later on in 19th century, some subatomic particles has been discovered by different scientists. So we have given different further informations in your module. So with the certain experiments, they have discovered there are subatomic particles. Subatomic. Okay, if I ask what are the subatomic particles, then you should explain electron, protons and neutrons are the subatomic particles. උපපරමාණුක අංශු හොයාගත්තා පස්සේ කාලෙක. ඩෝල්ටන්ගේ atomic theory එකෙන් consider කර atom is the basic unit of මූලද්‍රව්‍යයක තියෙන basic unit එක chemical reaction එකකට involve වෙන basic unit එක atom එක, but inside the atom also there are subatomic particles. So how they are arranged? So what are the properties of them? Then that was the question. So atom is composed of electron, proton and neutron, and protons are positively charged particles. So usually the unit that we are measuring the mass of an atom is called as atomic mass unit or AMU. If I consider the mass of a proton as atomic mass unit of 1 atomic mass unit, then the mass of a neutron also same as the proton. But the thing is that proton is positively charged, but neutrons does not have a charge. In case of electrons, they are negatively charged particles and their mass is 1 out of 1840 of the mass of a protein. Protonic ස්කන්ධයෙන් 1841 1 over 1840 of the mass of a protein. That is the mass of an electron, that is less mass compared to proton. But the charge is also different, that is negatively charged. And the other important thing is, usually the atom is a neutral one. If it is neutral, so the positive and negative charge should be in a same. So that means number of protons and number of electrons present in a particular atom should be same. Then only the atom can be a neutral one. Both protons and neutrons are collectively known as nucleon, and both proton and neutron are present inside the nucleus. But this was discovered later. Before that, the scientists have given different structures of the atom. So here you can see mass. If I get it as a atomic mass unit, proton is 1 atomic mass unit, neutron also 1 atomic mass unit, but electron is 1 over 1840. Charge proton positive, electron negative, and neutron does not have a charge. So then how can be a neutral? Atom can be a neutral if it is so positive negative charges should be balanced and should be same. So based on that, then the different scientists, they have given a different atomic model. So after the Dalton theory, J.J. Thomson, Rutherford, Bohr, and later on, wave mechanical model is the one which is acceptable at the moment. So you can see the timeline. So the Dalton, he didn't discover any subatomic particle. He thought that atom is a solid kind of a ball-like thing. But later on, Thomson believed that that time positive and negative charges, photon electrons have already been discovered, and he thought that positive negative charges are exist as a plum pudding model like this. So he explained it as a plum pudding model. Okay. So the Dalton he thought it as a billiard ball. Now Thomson thought that positive negative equal charges, then positive charges are embedded in negative charges as a plum pudding model. But the most acceptable way was expressed by the Rutherford later. He explained that there is a center called nucleus, and in the nucleus, proton and nucleus are present, and electrons are revolving around the nucleus as in planets revolving around the sun. So in our solar system, අපේ solar system එකේ ඉරවට ග්‍රහලෝකය යන විදිහටම තමයි atom එකේ න්‍යෂ්ටිය ඉලෙක්ට්‍රෝන හා න්‍යෂ්ටිය ප්‍රෝටෝන හා නියුට්‍රෝන තියෙනකොට ඉලෙක්ට්‍රෝන ඒවට ගමන් කරනවා කියලා කිව්වා. So the Rutherford Bohr also explained, added certain things to that. So now the Rutherford accept the nucleus is there. So this is the nucleus. It's having neutron and proton. Proton positive charge, neutron does not have a charge. And electrons are orbit or revolving around the nucleus. And then Bohr explained those revolving of these electrons are revolving in a constant energy levels. There are energy levels, Shakti Mattanti. So they are revolving around the energy levels. So the electrons are revolving or orbit around the nucleus in a particular energy levels. Same thing, atom structure, electrons, protons, neutrons are in proton, neutron in the center, nucleus, and electrons are revolving around a particular energy levels. So, so that was the one which was acceptable at the moment, and we can explain other chemical bonding and other things based on the structure of the atom. That is, center is with the neutron and proton, and electrons are the one which are revolving around the nucleus in a certain energy levels, and electrons are the one which are involved in chemical reactions. They are the one can move from here and there, not the proton and neutron. They are in a center. And mass of the atom is determined by neutron and proton in the center. But because you know that they are the having heaviest one, they are the heaviest particles. Electrons are very less dense particles. So therefore, the mass of the atom is determined by neutron and the proton. And electrons are the one which are involved in chemical reactions. They are the one can move from one energy level to another energy level and from one element to the other element and forming a chemical bonds. So the movement of these electrons from one to the other to form a chemical bond, that is to be a stable one. So anything, I mean in nature, usually, so everything is having a stable energy. So always any matter is trying to be a stable with a less energy. So in order to be stable, that's why atoms are trying to form a chemical bonds to be stable. So then tomorrow you will learn how these chemical bonds are formed in between elements and to form compounds and why they are forming such chemical bonds. So based on this structure, now we can identify three things, atomic number, mass number, and the isotopes. Atomic number is the number of protons in the nucleus of each atom of an element. Number of protons present in atom. So the atomic number equal to number of protons, as number of protons are equal to number of electrons in an atom which is neutral. As the atom is neutral, proton and electron number should be same. Therefore, atomic number is equal to number of protons and also it is equal to number of electrons. So, chemical identity of an atom can be determined solely by atomic number. Using this one atomic number, later now we will discuss later, periodic table has been constructed. And the mass number is a number of protons and neutrons present in the nucleus. So the summation of protons and neutrons of an element is given as a mass number. Atomic number is denoted as Z. Mass number is denoted as E. So when you are expressing mass number and the atomic number, this is the usual way. The element symbol is given like this. And as a subscript value, you can give as the atomic number. As the superscript value, we can give the mass number. For example, in carbon, atomic number is 6 and mass number is 12. This is the way that we are representing. So the atomic number has a subscript value and the mass number is as a superscript value. පරමාණුක ක්‍රමාංකය atomic number එක අපි subscript value එකක් විදිහට දෙනකොට ස්කන්ධ ක්‍රමාංකය mass number එක අපි superscript value එකක් විදිහට element එකට උඩින් පෙන්නනවා. එතකොට carbon වල atomic number is 6 and mass number is 12. So just by looking that in your chat box, please tell me how many protons are present in carbon, how many electrons are present in carbon, and how many neutrons are present in carbon. Quickly. Give me the answers. How many electrons, protons, and neutrons are present in carbon? So now I have given the atomic number and the mass number of carbon. Yes. Very good. Others? තුනෙක විතරයිද තේරුනේ? Yeah, all are 6. So here, atomic number 6 means proton. Atomic number is equal to number of protons. Therefore, proton number also 6. And number of protons and number of electrons should be same as atom is a neutral one. Therefore, electron number also 6. And mass number is a summation of proton and the neutron. Therefore, the protons are 6 and total is 12. In order to be 12, the neutron number should be 6. Very good. Other thing is the isotopes. Samasthānika කියන එක. I think the atoms of an element that have the same number of protons but different number of neutrons. Or atoms of an element that have same atomic number but the mass number is different. That is because of the changing of the number of neutrons. They are said to be isotopes of the particular element. Usually oxygen has 3 isotopes as oxygen atomic number is 8 and mass number is usually 16, but it has another 2 isotopes as 17 and 18. That is the changing, only now changing the difference is with the neutron, number of neutrons. Hydrogen also, usually hydrogen atomic number is 1, mass number is 1, but hydrogen is having another 2 isotopes as deuterium and tritium, mass number 2 and mass number 3. As the chemical properties are determined primarily by protons and electrons in an atom, neutrons do not take part in chemical changes under normal conditions. Therefore, isotopes of the same element have similar chemistries. So this is so you can quickly complete this one. So I have given certain values. So based on that, you can fill the rest of the thing. Now you can give the answers. Anyway. Sodium first. The 3 spaces in sodium. So please give the answers for the sodium first. Atomic and mass numbers are given. Chat box. Proton, sodium, you can write Na, proton, electron, neutron. And oxygen, electron, neutron, atomic number. Likewise, you can give the answers. Sodium first. Yeah, sodium, proton, atomic number is 11. Okay. Sodium, how about the others? So I can give the similar kind of thing for your exam also to fill up the things. But unfortunately, even though I have explained in a right away, this is very simple thing, very basic things in the chemistry. අපි කතා කරන්නේ බොහොම basic things in chemistry. But I don't know why the most of your colleagues in previous batches they didn't complete this one during your exam also. So very easy thing and nothing to think about that. Okay. Okay. In sodium, it is 11 protons, 11 electrons, and 12 neutrons, as mass number is 23. Oxygen, so you can try this one later. Oxygen 8, 8, 8, 16. So as the proton number is given, now oxygen become atomic number also 8. And the electron also 8, as mass number is 16, neutron also 8. Now you have given proton and electron in radon, then the atomic number is 86 because it is equal to proton number, and you have to get the summation of proton and neutrons. So then you have to calculate, I think it's 222. Likewise, you can fill up just by looking at the given data, you can fill up the table easily. Please try to do this one later by yourself and get the idea of that. How this, what is atomic number, mass number, and how, based on that, how do you find out number of protons, electrons, and the neutrons? So based on this atomic number, now the scientists have developed a periodic table by placing the elements with the similar chemical properties and physical properties. They have placed those similar characters, the elements with the similar characters in a way that they are coming to one particular groups. Then it is easy to study them. Otherwise, it is very difficult to keep in mind the properties of each and every element one by one. But as a group, if we can keep it in mind, then it would be easy their properties. So they have placed these elements in a way that the atomic number is increasing, and they have identified a kind of a fashion order that can have a similar characters in one particular group, the repeating of them. For example, here the first group is hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Those are sharing similar properties. Beryllium, magnesium, calcium, strontium, barium, those are sharing similar properties. In the other side also, each and every group are sharing similar properties. Helium, neon, argon, krypton, xenon, radon, those are known as rare gases. Nishkriya vayu, they do not involve in any chemical reactions. Helium, neon, argon, krypton, they are rare gases, or අපි කියනවා සිංහලෙන් නිෂ්ක්‍රිය වායු. And then the other fluorine, chlorine, bromine, iodine, those are halogens. So likewise, they have identified a kind of order. Once they place elements in an increasing order of atomic number. So here you can see the top number is atomic number. In a periodic table, actually they have placed the atomic number as the top of the square, okay, top of the element. So don't mess up with the way that we are representing the atomic number and the mass number. Atomic number එකයි mass number එකයි සාමාන්‍යයෙන් element එක උඩින් තියෙන්නේ, mass number එක යටින් තියෙන atomic number. But in the periodic table, that is different. They have denoted the atomic number at the top of the element. Okay. But really, usually, the way that we are expressing atomic number in the mass number is, atomic number is usually as a subscript value at the bottom of the element. At the top of the element, we represent mass number. Okay. So here they have mentioned the way that they are placing the value symbol, element symbol in the middle. The bottom, they have indicated the mass number, and the atomic number in a periodic table is given at the top, because they have placed the element according to the increasing order of atomic number. In order to easily identify that one, that's why they have placed the number at the top. උඩින් දාලා තියෙන්නේ අපිට ලේසියෙන් අඳුනගන්න. So hydrogen atomic number 1, helium 2, 3, 4, 5, 6, 7, 8. Likewise, it is going on. We'll study this one later in detail. Then the atomic mass unit. I told you the atomic mass unit is the one which is used to measure the mass of an element, mass of an atom. So as atoms are very small particles, mass of an atom is measured by a smaller specific scale called atomic mass unit. Usually, one atomic mass unit is equal to 1/12 mass of the carbon-12 atom. Carbon 12 සමස්ථානිකයේ ස්කන්ධයෙන් 12 එකකට සමානයි එක atomic mass unit එක. So that was identified experimentally. One atomic mass unit is equal to 1/12 of the mass of a carbon-12 isotope or atom. Carbon, there are different isotopes. So we take the carbon-12 isotope. So one atomic mass unit is equal to 1/12 of the mass of carbon-12 atom. Mass of an atom of an element is expressed compared to the atomic mass unit. Then the average atomic mass. Most elements in nature exist as a mixture of isotopes. So the average atomic mass of an element with isotopes is determined by using the masses of its various isotopes and also their relative abundances. We have to consider their relative abundance, same time the mass of each and every isotope. So please consider this example. So this kind of similar one could be appeared in your exam paper also. I have taken it from your review questions. 7th one, a sample of oxygen contain different isotope. So the isotope with a mass 16 exists as 19.76%, 17 exists as 0.04%, 18 exists as 0.2%. So calculate the average atomic mass. How do you calculate the average atomic mass then? So then average atomic mass 16 into, so we have to consider the relative abundance. 16 abundance is 99.76. 16 multiplied by 99.76 divided by 100. Then plus 17 multiplied by 0.04 divided by 100 plus 18 multiplied by 0.2 divided by 100. So that is the way that you have to calculate average atomic mass. If you are taking the average value of 16, 17 and 18 added together and divided by 3, that is totally wrong. Okay? කලින් සැරේ අය 16 17 18 එකට එකතු කරලා 3න් බෙදුවා වැරදි. It's wrong. You have to consider the relative abundance is 16 existing 99.76%. How much about 16 out of 99.76%? How much out of 17? How much out of 18 existence? Then you have to add them together. But no need to divide by 3 again. Okay. Please go through the finding of average atomic mass. මේ calculation එක කරලා practice කරන්න. That's so important. Okay. So if you have any questions, you can ask right now. Let's move to the periodic table. After the periodic table, after discussing that, we can move to the quantitative analysis. Most important part, that one also. So then the rest of the periodic table again important, and we are going to discuss about electron configurations, how to write the electron configuration. Definitely that kind of question appeared in your paper as well. So I'm telling always this, stressing the points that you have to go through regarding the exam point of view as well. So please keep it in mind. කවුද batch rep ඉන්නවද ප්‍රමෝද් නේද? batch rep කවුරු හරි ඉන්නවද මේ group එකේ? උදේ 70 ගානක් join වෙලා හිටියා. දැන් ඉන්නේ 50 ගානයි. ඒගොල්ලෝ වැරදිලා අනිත් link එකට log වෙලා නැතුව ඇති නේද? Because after lunch I will start with the next link. lunch එකෙන් පස්සේ අපි ඊළඟ එකෙන් පටන් ගමු. කවුරු හරි වෙන link එකකින් අනිත් එකෙන් log වෙලා නම් කියන්න please come with the previous link. The periodic table of the elements. So the recognition of periodic regularities in physical and chemical behavior and the need to reorganize the large volume of available information about the structure and properties of the elemental system led to the development of the periodic table. So the periodic table is a chart in which elements having similar chemical and physical properties are grouped together, as I mentioned earlier. So in modern periodic table, elements are arranged according to the increasing order of the atomic number. So it is shown above the element symbol I have shown you. So horizontal rows of the periodic table are known as periods and the vertical columns are known as groups or families. In our current periodic table, scientists have listed 114 elements. So they are arranged according to the periodic law. ආවර්තිතාව නැවත එකම ගුණාංක හමු වෙන එක. Periodic law. That is, when elements are arranged according to the increasing order of the atomic number, their physical and chemical properties are found to show a repeating or periodic pattern. So that's why they can be arranged, group the elements according which are sharing the similar properties. When the elements are arranged according to the increasing order of the atomic number, so the scientists have denoted that we can group them according to the physical and chemical properties of them. So they show the repeating of these properties after some point. So likewise. So here the groups, the horizontal rows are known as periods and these are columns or the groups. This side are periods. Okay. So hydrogen is placed as a 1, helium is placed as at the end, and hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, likewise it's going on. So and initially it's having 8 elements, 2 elements, 8, 8 and 18, 18 likewise it is going. So here middle section there are 10 elements and this is first group, second group, third, fourth, fifth, sixth, seventh and eighth. Okay. Middle section is sharing the properties with different properties. We'll come to that point, and the bottom two are representing another different set. So the first 2 sections and the last 6 sections are sharing different things. Anyhow, the first column group sharing similar properties, second group sharing similar properties, third group sharing similar properties, likewise it's going. The 8th group, as I mentioned, they are rare gases, nishkriyava, they do not involve with the chemical reactions. Groups of periodic table can be labeled in three different ways, either Roman numerals with A and B. So the three different ways are all three different ways present in here. Either with Roman numeral and A and B. So the first one, 1A, 2A, and the last six sections, 3A, 4A, 5A, 6A, 7. And the middle sections are labeled with another way, 3B, 4B, 5B, 6B, like that. Either or less, you can have 1, 2, 3 like that with the Arabic numerals without A and B designation. That is the standard way, IUPAC nomenclature. And the other way is Arabic numeral A and B designation with the Arabic numerals 1A, 2A, 3A, B, 4A, like that. Element 113 and 115 and 218 not yet synthesized, and 110 to 112, 114 recently synthesized, not yet named. And again, elements can be broadly divided into three categories. They are metals, metalloids, and non-metals. Loha, aloha, ubhyaguni, loha. Metals, non-metals, and metalloids. So the last section represents metals. First two groups, middle section, they are metal, loha. And the right-hand side, most right-hand side represent non-metals. And this row, this diagonal way, you can see the purple color elements, they represent metalloids. And the bottom two rows, periods, also represent metals. So in our periodic table, so far identified animals, out of the so far identified animals, last sections represent as metals. Hydrogen and helium both are non-metals. So the non-metal metal is good conductor of heat and electricity. Non-metal is usually poor conductor of heat and electricity. Metalloid has properties that are intermediate between metal and metalloids. So only 17 elements are non-metal, 8 are metalloids, and others are metals. Usually when you are moving from left to right of the period in a periodic table, metal properties are changing gradually to non-metals. So periodic table is a handy tool that correlates the properties of the elements in systematic way and help us to make prediction about the chemical behavior. Elements in a group of periodic table have similar properties because they have same type of arrangement of electrons in the periphery of the atoms. So later we will see how these electrons are arranged in an atom. So when you are writing the electron configuration, so some elements groups have been given a special name. As I mentioned, the last group 8B, 8A, noble gases or rare gases. Noble, rare gases, they do not involve in chemical reactions of equivalent can be nishkriya by. Group 1 is known as alkali metals. Here it is. So the group 1A is, these are alkali metals, okay? 1A, from lithium to this francium are alkali metals. So these are beryllium, magnesium, calcium, strontium. They are alkali earth metals. The first group, hydrogen, is not a metal. It is a non-metal, okay? Keep it in mind. And as I mentioned, the seventh group is known as halogen. This group is halogen. And there are, in this block, you have coinage metals. කාසිලෝහ කියලා අපි කියන්නේ coinage metals. So, coinage metals, copper, gold, and silver, they are coinage metals. Then see the most important section, how these electrons are filling into the atom, in the atom. So electron configuration. Bohr, so for that we are using Bohr model of the atom. So Niels Bohr proposed the Bohr model of the atom in 1915. Because the Bohr model is a modification of the earlier Rutherford model, who proposed that electrons are revolving around the nucleus as in a solar system. So this Bohr model is again named as Rutherford Bohr model. They postulated the structure of an atom on the basis of quantum theory. So how do they propose? So the atom consists of a positively charged nucleus at the center, and it's having proton and neutrons, and electrons revolve around the inner fixed orbits. කාක්ෂික නියත කාක්ෂිකවල එහෙම නැත්නම් energy levels. The electrons are revolving around fixed orbit or energy levels. So each orbit having different radius from the center. Each orbit having different radius from the center. Okay, B, C. Different radius are there. Then each orbit is associated with a definite energy, and therefore they are known as energy shell or energy levels, denoted as N. And the shell or energy levels which are nearest to the nucleus having lowest energy or minimum energy, and shell which are far from the nucleus having maximum energy. And electrons are always try to be in the lowest possible energy level. In any case, if they have absorbed energy, they can move to the upper energy level, but quickly they are trying to come to the lowest possible energy while releasing their energy. Therefore, electrons are always trying to be in a lowest possible energy. As I mentioned, in order to be stable for any of the matter, they have to be with the lowest possible energy. Otherwise, they cannot be in a stable manner. අපිට ශක්තිය එන්නේ නැ වැඩි වුණොත් අපිට higher position එකක ඉන්න බෑ. We are not stable at that point. So always any item in the nature is trying to be in a lowest possible energy. Then only they can be stable. So the arrangement of energy levels around the nucleus. So we can name those energy levels as with the letters of K, L, M, N, O, P, O, 1, 2, 3, 4, 5, 6. Likewise, those orbits or shells or energy levels we can represent in any kind of way. So the normally electron exists in ground state, meaning they occupy the lowest energy level possible, which is closer to the nucleus. So each energy level can accommodate maximum number of electrons. There is a limitation. The first energy level, this one, which is closest to the nucleus, can hold only 2 electrons. The next one can hold 8, third one 18, fourth one 32. After that, all the energy levels are getting 32 number of electrons. But initially, first one 2, second one 8, third one 18, and our fourth one 32, fourth one onwards, all are holding 32 electrons. So how this number is going to be determined? So these are the orbits where the electrons are revolving or the energy levels. Then, with the modern atomic theory, the wave mechanical model, I told you after the Bohr and Rutherford Bohr model, there is another model called wave mechanical model. In that, it considered that the electrons have properties of both waves and particles. The major difference between Bohr model and the wave mechanical model is the way that the electrons are pictured. Instead of moving in fixed orbit, the electrons move in areas called orbitals. Orbital is described as a region in which electron of a particular amount of energy is most likely to be found. So based on this wave mechanical model, which was expressed by Erwin Schrödinger in 1926, so this model explained probability that the electron will be in a certain region of a space at a given state rather than in an exact location of electron. Electron වලාවක් විදිහට තියෙනවා කියලා තමයි එයා කිව්වේ. But based on these informations, now what we are going to represent, this model retained the idea of still the orbit's principal energy level. However, they distinguish another sub-level called orbital, Upakakshika. The shell or main energy level with a principal number, simple n, also consists with sub-energy levels called SPDF. 4 sub-energy levels they have identified as SPDF. And each sub-energy level consists of specific number of orbitals. So the maximum number of electrons that each orbital can accommodate is 2. එක orbital එකක එක උපකාශකයකට තියාගන්න පුළුවන් 2යි. බෝහා රදපඩ් හොයාගත් කිව්වා ප්‍රධාන ශක්ති මට්ටම් තියෙනවා. මේ ප්‍රධාන ශක්ති මට්ටම් වල තමයි ඉලෙක්ට්‍රෝන ගමන් කරන්නේ. Wave mechanical model එකත් එක්ක ඒගොල්ලෝ කිව්වා ප්‍රධාන ශක්ති මට්ටමට අමතරව උපශක්ති මට්ටම් තියෙනවා. They are known as orbitals. And they have identified ඒගොල්ලෝ හොයාගත්තා 4 different orbitals as S, P, D and F. And each orbital can accommodate only 2 electrons. So likewise, now the orbitals you can see in a second major energy level. So this is, if I consider this one as the major energy level, second one, so it's having S and P sub-energy levels. In S is in a round shape, circular, and the dumbbell shape with the P sub-energy level. And P sub-energy levels also having 3 orbitals. So therefore, this one can accommodate 2, and this 2, this 2, and this 2. Altogether, the second energy level can accommodate 8 electrons. That's how that earlier we mentioned that the first sub-energy level only can hold 2 electrons. Second one can hold 8 electrons. So 8 electrons can hold because of having S sub-energy level and P sub-energy level. So P is having 3 orbitals. So the sub-energy level is PDF. Number of orbitals in each subshell is S is having 1 orbitals. Sub-energy level, number of orbitals, S sub-energy level 1 orbital, so can accommodate only 2. P sub-energy level is having 3 orbitals, therefore can accommodate 6. D sub-energy levels having 5 orbitals, 1 can hold 2, altogether 10. If sub-energy level is having 7 orbitals, therefore 1 can hold 2 and altogether 14. So now you can see the relationship. There are main energy levels as 1, 2, 3, 4. First main energy level, you have only S sub-energy level, 1 orbital, only 2 electrons. That's why we said that first energy level can hold only 2 electrons. When you move to the second main energy level, it is having 2 sub-energy levels as Upashakti Mattan තියෙනවා, S and P. And S is having only 1 orbital, P is having 3 orbitals, so S can hold only 2, P sub-energy can hold now 6, altogether 8. That's why second energy level is having 8 electrons. Third main energy level having SPD sub-energy level. S is having 1 orbital, P is having 3 orbitals, D is having 5 orbitals. Therefore, S can hold 2, P can hold 6, D can hold 10, altogether 18. That's why third energy level can accommodate only 18. When you go to the fourth energy level, you have S, P, D, F, all 4 sub-energy levels. S 1 orbital, P 3 orbital, D 5 orbital, F 7 orbitals. With that, you can have 2, 6, 10, and 14. And altogether, you have 32 electrons. Therefore, fourth energy level can hold 32 electrons. From this point onwards, all energy levels, 5th, 6th, 7th, likewise, all energy levels are having all 4 sub-energy levels. Therefore, all can accommodate 32 electrons. Okay, this is how electrons are accommodating into each energy levels and sub-energy level. So the S orbital usually round shape, all other orbitals are having dumbbell shapes. This is D. Then what is electron configuration? Electron configuration means the way in which the electrons are distributed among the various orbitals of an atom. This is known as electron configuration. So the filling of electrons in the orbital take place according to the increasing order of the energy of orbital. ශක්තිය වැඩි වෙන ආකාරයට තමයි මේ electron orbitals වලට පිරීම සිද්ධ වෙන්නේ. Usually it says that compared to S, the P sub-energy level is having high energy compared to Phi. D is having higher energy compared to D. F is having higher energy. So this is the order that the electrons are placed. So first of all, starting with the S, then P, then T and F. But there is a kind of a deviation at the third and fourth likewise energy levels. I will explain them later. So the first energy level, so you have only one sub-energy, so therefore it will be filled up. පළවෙනියටම S එකට පළවෙනි එකේ තියෙන S sub energy level එක විතරයි. S orbital එකට electron දෙකක් පිරුණා. Now 2 electrons are filled to the first sub energy level. Okay. And when you go to the second main energy level, so you have S and P sub energy levels. First of all, fill into the S sub energy. After filling 2 electrons to the S sub energy, then move to the P and then complete the P sub-energy level with the 3p orbitals are there. Then move to this third energy level. It is having S, P and D. So first filling to the S. So first filling to the S sub-energy level, 2 electrons. Then move to the P sub-energy level, so complete with the 6 electron. Then as according to the order, it should have moved to the third 3D, D sub-energy level, because third level is having SPD. But compared to D sub-energy level in third main energy level, S sub-energy level of the fourth main energy level is having lowest energy. තුන්වෙනි ශක්ති මට්ටමේ තියෙන D උපශක්ති මට්ටමේ ශක්තියට වඩා fourth main energy level එකේ තියෙන S උපශක්ති මට්ටමේ ශක්තිය අඩු හින්දා third එකට 3D එකට කලින් 4S ට fill වෙන්න පටන් ගන්නවා. Okay, after completing with the 4S sub energy level, then fill into the 3D level, and after that again fill into the 4P. Okay, from that point, the difference is going on. Then again, not the 4D, again 5S is filling. After 5S, 4D is filling. Then 5P is filling. And after 5P, SPDF is there. No? From fourth one onwards, you have F sub-energy level also. You can see only S and P is filling. In fourth one, then move to the S level. Again, 4D is filling in the fifth main energy level. And then 5P is filling. And then again move to the sixth level, 6S. After 6S, 4F will start to fill up. And complete 5D, then only 6P is going. Likewise, the order of electron filling is a little bit different. So it's not easy to, since it's difficult to keep it in mind, you can have a chart like this. Then you want to by heart this order. You can write first main energy level, you have 1S only. second 2s 2p, third 3s 3p 3d, fourth 4s 4p 4d 4f, fifth 5s pdf, sixth s pdf likewise. So you can make it an arrow like this in this way. Okay, 1s, 2s, 2p then 3s, 3p to 4s, 3d 4p 5s, 4d 5p 6s, 4f 5d 6p, 5f 6d likewise. So first you can draw this one, then you can easily write any electron configuration. Shall we write electron configuration of calcium? Not the calcium. Let's write one. Yeah, first we'll write the electron configuration of sodium and potassium. So the sodium atomic number is 11. So the potassium atomic number is 90. So now we are going to show how these electrons are filled up in energy levels and in sub-energy levels using electron configuration. So let's write electron configuration for sodium and potassium, 11 and 19. Can you start writing? Sodium atomic number is 11, potassium it is 90. පුළුවන් ද ලියන්න මම එකක් පෙන්නන්නද? Sodium atomic number is 11. So how you can write? So first electron is filling to 1s. 2. 2. Then දෙකක් ගියා. So then next electron is going to second energy level and S sub energy level. Now complete with that 2. Now it's still 4. Then the next 6 electrons can be filled to the 2p sub-energy level. So it can accommodate only up to 6. Now altogether we have 10 electrons are already over. So still one is remaining. Now that is going to third level, third main energy level, S sub-energy level and 1 electrons. Okay. So now altogether you can have 11 electrons in sodium. First fill first 2 electrons to the first energy level, S sub-energy. Then move to the second main energy with S and P, 2 and 6. Then move to the third sub-energy level called 3s. wait a minute. So move to the 3s sub-energy level. So then sodium and then potassium. Okay, you can write down as in that way for the potassium. Potassium atomic number is 90. Can you please write it? Please give it in chat box. Okay, a few of you have given the answers. 1:2, 2:2, 2:6. So no need to separate each and every sub-energy level. So when you are give the comma once after each and every major energy levels. Okay, 1:2, 2:2, 2p6. Likewise. So now, as in the given in the slide, you can see 1:2, comma 2:2, 2p6. After that, 3:2, 3p6. Then the next order is 4s, 3d, 4p. After that, comma. Likewise, you can go ahead. Otherwise, you will be confused with that. So some of you have didn't get the idea. Now, first, the 19 is the potassium. So first one, 1:2 should be there. So I will write it again. Still, D sub energy level has not been started. D එකට පිරෙන්න පටන් ගත්තේ නැහැ. බලන්න මේ D එක දාපු එක්කෙනා. So you can count the total number of electrons. Once you write the electron configuration, count the total number of electrons and check whether it is tally with the atomic number. So let me write the 19. 1:2, 2:2, 2p6, so then 1:2, 2:2, 2p6. So first filling to the first sub energy level, first main energy level, S sub energy level after completing. So then move to the second level, 2 electrons filling to the first level. Then second S complete with 2, then filled with P. ඒක සම්පූර්ණයෙන් පිරුණාට තමයි පස්සේ තමයි ඊළඟ එකට යන්නේ. Okay, once it completely filled, then move to the next one. Likewise. So then start with the third level. So then still third level, 2 electrons. Now count it. Still 12. So therefore go to the 3p. 3p. 6. Now it's having 18 electrons. After 3p, even though 3d should be there, but since the energy is less in 4s, now start to fill up to the 4s instead of 3d. 4s1. 1:2, 2:2, 2p6, 3:2, 3p6, and 4s1. So again, you could understand something in here. So the sodium and potassium in first column of the periodic table. After sodium, then the potassium is coming. And you can see at the last energy level is both are having 1 electron. The last energy level, both are having 1 electron. First periodic table, first column. So the column number is now equal to the number of electrons in last energy level. So now you can see another relationship here. The number of first column is having 1 electron in last energy level. Second column is having 2 electrons. Third, 3. Likewise, it's going. We'll come to that point. Okay, we'll see the relationship. So let's see the third energy level. අපි බලමු, we'll say another example with the D sub-energy level. Then you could understand how it's coming. Let's write the electron configuration of scanedium. Let me check the atomic number. So the atomic number of scanedium. Scanedium is 21 atomic number. So you can quickly write down the electron configuration of scanedium. Atomic number is 21. Diyanna බලන්න. Please put into the chat box, okay? 21. Scanedium. Electron configuration is 21. One minute. You can put it into the chat box within 1 minute. Quickly. Yes. Others? Only one of you have given the answer. Okay, good. 20, 185, Suru. Others? Yeah, 231. 197. Yes, correct. 205. Very good. Okay, you got the idea. So here now start with 1s, first energy level, 2 electrons filled. And after that move to the second energy level. So the remaining electrons now moving to the second sub-energy level S. Now only can accommodate 2 field. Then the rest electrons again move to the P sub-energy level. It can maximum accommodate 6. That is also filled. Still there are more electrons. Now move to the third energy level. So then complete with S sub-energy level still can accommodate 2 field. But still there are more electrons. Then move to the next energy levels, that is 3p sub-energy. It can also accommodate 6. Now altogether how many? The 18 electrons has already completed. Then now still we have 3 more electrons to be filled. But still we cannot go for a 3D as energy of 4s is less than 3D. So I start to fill with the 4s first. So the 4s can accommodate 2. So once you got that 2 electrons to the 4s, still now how many? 20 electrons are already completed. But still we have 1 more electron to be filled. Now, since 4s has already completed, now you can start the filling electrons to the 3d level, and then 3d is having 1 electron. So now you can see is now from scandium onwards start to fill up electrons to the d sub-energy levels. Okay, so so that's how electrons are filling to the atoms of an element according to the increasing order of the energy levels. Let's see the relationships with the electron configuration and the periodic table. So here you can also see the way that the electrons are filling. First in oxygen, atomic number is 8, 1s. After filling to 1s, move to the 2s, and then move to the 2p. Even for the 3 orbitals, so first all 3 orbitals, once they accommodate 1 electron for each, then start to the next, likewise. This is for the carbon. 6 is the atomic number. 6 electrons are filling over there. So the electron configuration of elements are related to their location in the periodic table. The periodic table is structured so that elements its same pattern of outer shell, or we say the electrons in outermost shell is known as valence electron. So the valence electron configurations are arranged in columns. As I mentioned, the group 1 always having 1 electron in S sub-energy level. You have seen in sodium and potassium. So the sodium electron atomic number is 11. Potassium atomic number is 19. Once you write the electron configuration, you have NP. So the here ultimately you have S1 electrons. So here the 3s1 and this one 4s1. Okay, so you can see in the last energy level you have S1 configuration. Therefore, group 1a is having common electron configuration for the outermost energy level as NS1. When you move to the group 2, it is NS2. So you can, when you write magnesium and calcium, magnesium atomic number is 12, calcium atomic number is 20. So the magnesium you will end up with 3s2 configuration. Calcium you will end up with 4s2 configuration in outermost energy level. Therefore, the outermost energy level electron configuration is common to all elements in the second group, that is NS2. So when you move to the next side, that is the right hand side, so you have starting to the electrons are filling to p sub energy levels. Same thing, this is what I mean, that valence electron. If you write the electrons in each and every energy level in sodium, First level you have 2, second level you have 8, and third level you have 1. Outermost energy level you have 1 electron in sodium. So this is known as valence electron. The electrons in outermost, electrons in outermost energy level is known as valence electron. So these are electrons in outermost energy levels are the one which are involved in chemical bonding. Here you can see one thing. So the first level already filled with the maximum number that they can hold. Second one also completely filled with the maximum it can hold. Third one still having 1 in order to be filled with the maximum. So it can also having sp3. So still it can hold maximum electrons, but still only it's having 1. So in order to be stable as sodium, in order to be stable, what it can do is, so this remaining one, the one in the outermost energy level can be moved to the, or can be removed. Once it removed, it can be stable. Sodium and outermost energy level එක electron එකයි. ඒ outermost energy level එක filled වෙලා නැහැ. complete වෙලා නැහැ. ඉතින් එයාට stable වෙන්න තියෙන හොඳම විදිහ තමයි අර outermost energy level එකේ තියෙන electron එක අයින් කරන එක. So then that's how it's going to be form a chemical bonding. So sodium always willing to donate this outermost electron. When you write the electron configuration of chlorine, so you can see chlorine is having outermost energy level 7 electrons, and 1 is still, if it can get 1, it can fill with 8 number of electrons, the maximum, and can be stable. So therefore, usually sodium is willing to take up electron and be stable. Sodium is trying to remove it and chlorine is trying to take it up. Therefore, if you can make sodium, once it remove, the chlorine can take up that one. It can form a chemical bonding between sodium and chlorine. So that's how chemical bonding is going to be formed. So you can tomorrow you will get the complete idea, in detail regarding chemical bonding. So the outermost electron is now said to be a valence electron. So then you can see when you move to the third group, so it is in a configuration of S and P, outermost energy level NS2, NP1, NS2, NP2, NS2, NP4, NP5, likewise it's going. So the group number and the outermost energy level electron number is same. So, and the eighth group, you can see eighth group, the last group, noble gases or rare gases, eighth group is having 8 electrons in outermost energy level, so completely filled, and therefore it does not involve with the chemical bonding. That's why they are said to be noble gases or rare gases. So according to the type of subshells being filled, again elements can be categorized as representative elements, transition metal, lanthanide and actinide series. So the representative elements are known as main group elements. First 2 columns and the last 6 columns are coming under representative elements. Elements with outer S subshell or P subshell are being filled are coming under representative elements. Okay. Group 1A to A, where outer subshell are being filled, they are known to be S block. Group 3A to 8A, P subshell are being filled, therefore they are said to be P block. So if I get it in. And the transition metals are the middle section, middle scandium, starting from scandium, elements in thin columns in middle. In transition metals, still electrons are belonging to d orbitals, therefore they are known to be d block. And which are placed at the bottom of the periodic table. Two periods are there. They are known to be lanthanide and actinide series. And also both of them are known as F block as the electrons are being filled into its subshell. If I go back to that quickly, so here I will get the periodic table again. Very slow. Okay, here. So the first group, this one, hydrogen, lithium, sodium, all are having one S in S1 configuration in outer shell. Second one, beryllium, magnesium, they are having NS2 configuration. And first and second columns are known as S block. This is S block. This is first two columns are S block. And from 3 to 8, this group, electrons are filling to p sub energy level. Therefore, this block is known as 3 block. Here, the configuration of outermost energy level is Ns2 to Np1. Here, Ns2, Np2, Ns2, Np3, Ns2, Np4. Likewise, it is going on, and finally, you will have Ns2, Np6, 8 electrons in outermost energy level. So the still electrons are filling to p sub energy level. Therefore, this section, rightmost 6 columns are p block. And the middle, this yellow color region is known to be d block as electrons are being filled into d sub energy. And bottom two are known as F block as electrons are being filled into F sub energy level. Therefore, those two lanthanide actinide series are known to be F block. Okay, now S block, P block, D block, and F blocks are there according to the sub-energy levels that the electrons are being filled. So then let's move to the other relationships. Let's see what are the other relationships. Okay. So elements are being filled. Elements are organized into rows and periods based on their outer shell number or outer energy levels. So the period number also represents number of main energy levels in the element. The first period, only one main energy level. Second, two main energy level. Third period, three main energy. So when you write the electron configurations, you can note that there are how many energy levels are there. Sodium in third period is having three main energy levels. Potassium in fourth period is having four energy levels. Likewise, fifth is having five main energy levels. Sixth is having six main energy levels. And likewise, it's going on. So you can see here, first one main energy level. Second, only two, S and P. Second one is 2, then 2s1, third one is 2, then second energy level 2s2, 2p6, and 3s1. Fourth one, three main energy levels are there. Fourth one, four main energy levels, likewise going on. And then number of elements in each period is equal to the pattern of electron filling into the subcells or sub-energy levels. So the electron filling order is 2, 8, 8, 18, 18, 32 like that. So first 2, second level 8, third level S and P, because 3D is going to be filled in a fourth energy level. Therefore second is 8, third level you have 8, and fourth level, you have 18, 18, and 32. Likewise, it's going on. Therefore, first period, you have two elements. Second, we have 8 elements. So, the number of elements in each period is similar to the pattern of electron filling into each sub-energy level. And also, the group number is equivalent to the number of electrons in outermost energy levels. Then, so this is only relevant to only S and P blocks, not for the D and F block, but for the S and P block, group number is equivalent to the number of electrons present in outermost energy level. So when you look at the ranging or the variation of the certain properties along the period and along the group, so we consider about atomic size, ionization energy, electron affinity, and electronegativity. So the atomic size, පරමාණුක අරය කියලා අපි කතා කරනවා. So the atomic size is when the electrons are going to be filled. So when you move from top to bottom in a column or a group, so you can see number of energy levels are increasing. First level, first period you have 1, second you have 2 energy levels, third is having 3 main energy levels, fourth is having 4 main energy levels. That means now what happened to their atomic size? පරමාණුක අරයට මොකද වෙන්නේ? So you can see the first one you have only 1, second you have 1 and 2, third one you have 3 main energy levels, levels. Fourth one, you have 4 main energy levels. Likewise. So therefore, atomic size is increasing from top to bottom. But when you're moving along the period, in one particular period, you have the same number of energy level. So you have only one particular energy level. Okay. So your number of energy levels are not increasing, but you know that from left to right, your atomic number is increasing. That means number of electrons present in outermost energy level is increasing. In the first column, you have only one electron. Second, you have two electrons like this. It's difficult for me to draw. And third one, you have three. Likewise, it is going on. And fourth one, the final eighth one, you have 8 electrons. Atakma තියෙනවා 8. Okay, likewise, 8 electrons are there. So even though number of energy levels are not increasing, but number of electrons in outermost energy levels are increasing. Therefore, there is a kind of a shrinking of the atom as the electron density is high in outermost energy level. Therefore, the atomic size is said to be decreasing along the period from left to right. So when you get the atomic size of sodium and the atomic size of chlorine, so which one would be higher? So let me say atomic size is higher in sodium compared to chlorine, or atomic size is small in sodium compared to chlorine. Which answer is correct? Either the first one or second one. Sodium atomic size is higher than chlorine, or atomic size of the sodium is less than chlorine. Both are in same period. Sorry. Which answer is correct? Yes, one of you have given the answer one. Yes, yes, another one. Others? Which answer is correct? Sodium is higher than chlorine, or sodium is less than chlorine. So this is also I can ask in the exam paper. Definitely this question can be appeared in your papers. Yeah? So please therefore try to understand. Yes, got it. So the first from left to right, when it is moving, so the atomic size is decreasing along the period. So the sodium is in first group, chlorine is in seventh group. Therefore, compared to chlorines, the sodium is having higher atomic size. So that is okay. Then when you come to the along the period, now we got the idea the atomic size is increasing. That is because of increasing the number of energy levels. So then the rest of the thing, ionization energy. Ionization energy is the energy which is required to release outermost electron. So when it is coming from top to bottom along the period, along a group, so what will happen now? You can see a number of energy levels are increasing, and outermost electron is from far from the nucleus. So now it's when you're moving from top to bottom. So at the bottom of the group, you have a high number of energy levels, and the outermost electron is far from the nucleus. Therefore, the attraction coming from nucleus towards the outermost electron is less. Therefore, there is a easiest. It is easy to move from the that electron can easily move from the atom. අන්තිම group එකේ උඩ ඉඳන් පහළට යද්දි top to bottom යද්දි energy levels ගන්න වැඩි වෙනවා. Number of energy levels ගන්න වැඩි වෙනකොට electrons outermost energy level එකේ තියෙන electron එකට nucleus එකෙන් දෙන attraction එක අඩු වෙනවා. එතකොට outermost energy level එකේ තියෙන electron එකට easily remove කරන්න පුළුවන් atom එකෙන්. Therefore, energy which is required to remove outermost electron from the atom is very low. Therefore, required ionization energy is very low. Therefore, ionization energy is decreasing from top to bottom in a group. But when you move from a longer period from left to right, as I mentioned, still it has having same number of energy levels, only the number of electrons are changing. So number of electrons are increasing as atomic number is increasing. So you have a higher density of electrons around the nucleus, and therefore since the increase in the number of electrons, the attraction from the nucleus to the electron is higher. And it's not easy for those one of these electrons to be removed from the atom. It requires more energy to be removed. Therefore, the ionization energy is from left to right is increasing. So when you get the sodium is having 1 electron outermost energy level, but in a chlorine there are 7 electron outermost energy level. So in sodium it is easy to remove 1 electron from its energy level, but in chlorine, as it's having 7 and high density of electron, it is not easy to remove 1 electron from outermost energy level. So that's why chlorine always willing to attract electrons, but sodium it's willing to remove the electrons. It's easy, with less ionization energy, it can be done. So therefore, ionization energy is decreasing along the period from left to right, but it is, so the ionization energy is increasing. ශක්තිය වැඩිපුර ඕන. Ionization energy එක වැඩිපුර ඕන electron එක remove කරන්න from left to right when you're moving from along the period. මේ පැත්තට යනකොට ionization energy එක වැඩි වෙනවා. Ionization energy is increasing. Okay? Increasing along the period. Increasing along the period. As it's not easy to remove electron from outermost energy level, so it requires highest energy to remove 1 electron from the outermost energy level. But when you move from top to bottom in a column or a group, so since number of energy levels are increasing, now the attraction from nucleus to the outermost electron is getting low, and therefore it is easy to remove the outermost electron. Therefore, ionization energy is getting low. And electron affinity is the one which is having an attraction. So the ability of attracting electrons from outside. So that ability is when you're moving from top to bottom along the group, the electron affinity is getting low. Electron ගැනීම හැකියාව අඩුයි. Electron නිදහස් කිරීම හැකියාවයි වැඩි. But when you come in from a period left to right, electron affinity is increasing. Rather than releasing electron, it's always willing to attract electron. Compared to sodium, chlorine is willing to attract electrons from outside. So therefore, electron affinity is also increasing along the period. And electronegativity means the attraction of electrons in a bonded electrons. When HCl is bond formation, so the bonded electron, so compared to hydrogen, chlorine is having attraction like this. When hydrogen and chlorine are forming a chemical bond by sharing its electron. Okay, So hydrogen is having one, chlorine is having outermost one electron. So now hydrogen and chlorine share in their outermost energy level electron and make a bond, covalent bond. So these bonded electrons, the chlorine is having high electronegativity. Therefore, they are trying to attract towards chlorine side. So this bond is become polar, Draviya now, because compared to hydrogen, chlorine is trying to attract electron towards it. Completely ගන්නවා නෙමෙයි සහයෝගයෙන් ඉන්නවා කියලා දෙන්න සහයෝගයෙන් තියාගත්තට chlorine ගේ තියෙනවා ඉලෙක්ට්‍රෝ ඇදගැනීමේ හැකියාව වැඩි හින්දා යාගේ පැත්තට ඇදීගෙන යන එකට. So electronegativity means that is the attraction of bonded electrons. So the attraction of bonded electron is getting high when it is moving from left to right in a periodic table, but it is getting low again from top to bottom. So that's how the each and every properties are changing along the period and along the group or a column. If you have any questions, you can ask right now. And so we have to do one more chapter again, that is quantitative analysis. This is the one which is based on the practical session also. So we are planning to do 3 practicals as titration, paper chromatography, and the spectrophotometer analysis. So today I will explain the theory behind those 3 practicals. Now it's almost 2 o'clock. So we can have a, what do you think? Shall I complete that one and, or we'll have a lunch break and do it? What is your idea? By 3 p.m. we can finish it all, I hope, if you didn't get any lunch break. If you are not going to have a lunch break, so මොකද කියන්නේ? Batch rate කෙනෙක් නැද්ද? මේ link එකෙන් එහෙනම් කරගෙන යන්න අපි. We can go ahead with the same link, I think. කවුරු chance එකක් දෙන්නේ නැහැ. Break එකක් ඕනේද නැත්නම් shall I continue without a break? Break එකක් ඕනේ නැහැ කියන එකද okay කියන්නේ? Okay, okay means we are going to continue without break. Is that so? Okay, go ahead. Let's continue. Yes. Okay, let's continue and then we can finish it off before 4, maybe 3 or 3:30. Yeah, then I will open up the next chapter, quantitative analysis. Let me share the chat. Okay. Quantitative chemical analysis. Under quantitative chemical analysis, let me So the under subject is, so what is going, it's moving ahead. Okay. So subject area of chemistry. So the organic, inorganic, physical and analytical and biochemistry I told you in the morning. So now here we are talking about analytical chemistry. So then analytical chemistry is the study of the separation, identification and quantification of the chemical components of natural and artificial material. So we can do this analytical process as a qualitative basis or quantitative. Qualitative means something, it's giving idea about whether present or absent. But in case of quantitative analysis, it gives the idea of the amount of the substance or components present in it. Qualitative එකේදී කියන්නේ තියනවද නැද්ද කියන අදහසක් විතරයි. Quantitative එකේදී measurable quantity එකක් දෙනවා. What is the amount present in the sample? So the analytical methods again can be divided into classical method and instrumental method. So classical methods also known as wet chemical methods. So for that we use so the analysis might be done based on the precipitation or maybe extraction or maybe distillation, and qualitative analysis by looking at color development, odor or melting point changes. Likewise, we can conduct classical methods. For the quantitative analysis under classical method, we use the measurement of weight or volume changes. So the different types of wet chemical method or classical methods are there. Qualitative analysis by chemical test or flame test. පහන්සිලු පරීක්ෂාව හරි අපිට chemical test එකක්. So the anions we can identify by forming a kind of another compound, maybe a kind of forming a precipitate. For example, so in order to check whether barium is there, so the usually barium, so sulfate is a precipitate. So if you can make it, for example, if you mix barium chloride with a H2SO4, then barium sulfate white precipitate will be formed. So likewise, you can use that kind of a chemical test to identify an ion, or maybe changing a color of the reaction. By the changing of color, we can identify, or less we can by making a kind of a fume or light thing, you can identify certain cations or anions. And or less we can use flame tests to identify certain elements. So I will upload has a certain different set of reference material in your LMS. In that I will upload a handout regarding this certain chemical test and flame test, qualitative test for you to refer. Then you can get the idea about what are the type of qualitative analysis. And gravimetric analysis determine the amount of material present by weighing the sample before and after some transformation. For example, If you want to measure the moisture content in a soil sample, so you can get the weight of the soil sample after getting before oven drying and after oven drying also. So you can do the oven drying of your soil sample up to at 105 degrees centigrade, and again you can measure the weight. So the weight loss indicates it's equal to the amount of water present in your or moisture present in your soil sample. Likewise, you can measure under gravimetric analysis. You can get the idea by with the weight difference. Volumetric analysis usually use the volume difference. So the titrations are coming under volumetric analysis. So the titration, anumapana, involve the addition of a reactant to a solution being analyzed until some equivalence point is reached. Often the amount of material in the solution being analyzed may be determined. In the instrument method, so we use a kind of instrument to get the measurements. So here it might be based on the light absorption, fluorescence, or conductivity, or maybe a kind of a separation technique with the chromatography or electrophoresis. So this is how qualitative analysis analyze presence of particular element or ion in a given sample using a qualitative sense. Quantitative analysis, volumetric or gravimetric. So volumetric, quantitative analysis is based on the volume, and the gravimetric quantitative determination is based on the difference of the mass of the solid. So the gravimetric analysis also can be done in a two different way, either precipitation by allowing to make a precipitate and get the mass of a precipitate, or else you can use volatilization method. As I mentioned, loss of the volatile species is analyzed there. So the determination of a soil moisture by volatilization method before and after getting the weight, after oven drying or before oven drying, and get the weight loss that indicates the moisture of the or water amount of the water present in your soil sample. That is the same way that we are determining the ash content of a soil or whatever the material. In a volumetric analysis, in your practical session, we will use volumetric analysis. Basically, we are using acid-base neutralization titration. There are several types of titrations: precipitation, oxidation, and complexometry. So we will discuss first acid-base neutralization titration. So in order to discuss acid-base titration, first of all, you should know what is acid and what is base. So acid can be defined acid and bases according to three different theories called Arrhenius theory, Lewis model, and Bronsted-Lowry model. Under Arrhenius theory, it says that acid are the substance that dissociate in water to produce H plus ions. And bases are the substance which that dissociate in water to produce OH ions in aqueous medium. So the problem is that this is only limited to the aqueous solution. So accordingly, HCl is an acid and it can produce H plus ion in water. Sodium hydroxide is a base as it completely dissociates and produces OH ions in water. But in Bronsted-Lowry model, it defines acid and base in a different way. It says any substance that can capable of donating a proton. Proton එකක් දෙන්න පුළුවන් නා. So that is an acid. Any substance that can accommodate a proton, accept a proton, that is base. When you look at the HCl here, I will show you. So here, water can accept HCl can donate a proton in here. Therefore, HCl acts as acid. And here water is acting as a base as water is accepting an electron. But with the reaction of ammonia, here ammonia is accepting a proton from a water and now water is acting as acid in here. Ammonia is acting as a base. Usually water is having a dual role, that is one. In certain cases it can act as an acid, in certain cases with the reaction of base it can act as an acid. But acid, HCl is also acid and a base. HCl acid because it can donate a proton. Ammonia is a base as it can accommodate accept a proton. In other side, hydronium ion H3O plus act as a acid and it can donate a proton. Chloride ion act as a base. So we say it's an ammonium ion act as a acid as it can donate a proton. OH ions act as a base in here. So this is not confined to aqueous medium, Bronsted-Lowry definition. So according to Bronsted-Lowry model, it says that always acid and base is having conjugate acid and base. So if I denote acid with the HA and base as a B, so here HA donate a proton to B and act as acid, B act as a base as it accepting a proton. In the other side, product side, A minus act as a conjugate base as it can again accommodate accept a proton. Now the formation of HB now acting as a conjugate acid and because it can donate a proton. But the Lewis acid-base concept is different. It says Lewis base is a substance that can donate a pair of electron and Lewis acid is a substance that can accept a pair of electron. අපි ඒක කතා කරන්නේ ඉලෙක්ට්‍රෝන දෙන නොදෙන එකෙන් එච්චර අපි කතා කරන්නේ ප්‍රෝටෝන දෙන නොදෙන එකෙන්. Here, unlike Arrhenius theory and Bronsted-Lowry model, Lewis acid-base concept, according to that, final product is not a salt and a water. Final product is a formation of coordinate covalent bond. දායක බන්ධන හැදෙන එකක්. So you will learn that one tomorrow. So here, hydronium ion formation with the H plus now act as an acid, H2 act as a base, and final product is a hydronium ion with a coordinate covalent bond. So the titration, so our basic practical. So the volumetric analysis refers to the quantitative chemical analysis carried out by determining the volume of a solution of a known concentration in a particular titration. අනුමාපනයකදී our purpose is to identify a concentration of an unknown solution. I mean unknown, not the unknown, concentration of a solution where we don't know the concentration. For example, we have a solution with a known concentration and we have a solution with unknown concentration. So we are going to titrate those two, known concentration with the unknown concentration. So we are going to have a reaction between them. And we are allowing to have a reaction between them. And once the reaction is completed, based on that, we are going to determine the unknown one. For example, like this. So in a burette, if you are going to titrate sodium hydroxide with HCl, that is the one that you are going to do in a practical. So we place the HCl in the burette. Usually, even though known or unknown, we place acid in a burette, not in the conical plus. Somehow, in a particular titration, the known concentration one we are placing in a burette and unknown concentration one we are placing in a conical plus. But if the known or unknown one of that is acid, usually we place that one in a burette. Acid එකක් අපි conical එකට දාන්නේ. Acid එක අපි දාන්නේ burette එකට. ඒක සාන්ද්‍රණය දන්නවා හෝ නොදන්නා වුණත් අපි burette එකට දාන්න. නැත්තම් සාමාන්‍ය titration එක කරන්නේ සාන්ද්‍රණය දන්න එක අපි burette එකේ තියෙනවා. සාන්ද්‍රණය නොදන්න එක අපි conical flask එකේ තියෙනවා. So the bottom you have a conical flask like this. So suppose this is sodium hydroxide. So now here you don't know the concentration, but we are adding known quantity in here. දන්නා ප්‍රමාණය දන්නා මවුල ප්‍රමාණය තමයි මේකට දාන්නේ. මවුල ගණන් හිතගෙන ගන්න, and the calculation you will study with the practical sessions. For the time being I'm trying to explain. So we are adding known quantity. අපි දන්න ප්‍රමාණයක් දාන්න. So usually the mole is represent. Mole means a number of any kind of entities present in the carbon-12 isotope is considered as a mole. And the quantity that can be present in a number of atoms present in a carbon-12 isotope is said to be Avogadro number, that is 6.022 into 10 to the power 23. 6.02 වැඩි කිරීම 1023ක් තමයි කාබන් 12 සමස්ථානිකේ පරමාණු තියෙන ගාණ ගන්නේ. එතකොට if you are getting any number of anything with a 6.022 into 10 to the power 23, we consider it as a 1. For example, so we say 12 mangoes as a 12 dozen. Same as that way, anything, if you can get it as 6.022 into 10 to the power 23. So we say it's a Avogadro number, and we say there is a 1 mole. If you count and get it the sand particles with 6.022 into 10 to the power 23, we say there is a 1 mole of sand. And if you can get the sodium atoms with 6.022 into 10 to the power 23, we say 1 mole of sodium is there. Same as that way. Okay. So likewise, so you will study those mole calculation tomorrow. So here we are using with known quantity, but concentration is, you don't know the concentration, but you are adding known quantity. So that's why here it's important to get correct volume. So usually we are adding 25 liter of particular solution in here. So we suppose that we are adding known quantity, but we don't know the concentration. අපි සාන්ද්‍රණය දන්නේ, නමුත් අපි දන්න පරිමාවක් add කරනවා, assuming that we are adding known quantity. And then here we know the concentration of HCl, and what we are doing in a titration, dropwise we are adding HCl to the sodium hydroxide, or the titrant to the titrant. Titrant is the one you are going to add. Titrant is the one you are going to measure. So dropwise you are adding that titrant, or here it is HCl, and then the reaction is going. So when you are adding each drop of HCl, so available sodium hydroxide, what will happen? Neutralize with that sodium hydroxide. So you can write the balance equation for this. Sodium hydroxide plus HCl and form sodium chloride and water. So this is the reaction. So first of all, you have to have a balance equation. So how do you see the balance? So all the things, or as I mentioned, the atoms cannot be created or distracted. All number of atoms should be same in reactant side and the productant side. So first look at the oxygen and hydrogen, as that is the one most highly event. So oxygen, here it is 1, here it is 1, okay. Hydrogen, here it is 2, hydrogen it is 2. Sodium, therefore 1, that is okay, chlorine is 1. Now it is already balanced. According to this, 1 molecule of sodium hydroxide reacts with 1 molecule of lithium, or in a mole, in the terms of mole, 1 mole of sodium hydroxide reacts with 1 mole of HCl. So the reaction ratio is 1:1. So once you are adding each drop of HCl consumed by sodium hydroxide and form sodium chloride and water. So it will going on until all the available sodium hydroxide is over. මේ ඔක්කොම අපි දාලා තියෙන known quantity එකක් දැන් මේ 20 millimeter 25. So this until this over, so this reaction is going on. Once you consume all these sodium hydroxide, so then the first drop of HCl, once it headed into the conical flask, there's no any formation of sodium chloride, and therefore still there is a HCl. So now the medium is becoming, earlier the medium was in basic, and now the medium is becoming HCl, acidic. So therefore now so we have to identify the point where all this reaction is completely happening. But somehow the point where completely the 1 mole react with 1 NCl, that is the complete end of this reaction. That point is known as equivalence point. මේ දෙන්න reaction එක completely සිදුවන තැන තමයි equivalence point. But somehow we cannot detect the equivalence point. In order to detect this point, we have added indicator. We are adding indicator which gives some color change. So usually those indicators are giving one color in acidic medium and another color in basic medium. So since early it is basic, it will give one color. Once just past this one, once it turns into the basic medium, it gives the another color. So at the time of completely consuming sodium hydroxide, it's not possible to detect, but just after 1 drop of that, medium become acidic, and then you can identify the point. That is known as endpoint, and that is the point where you have to stop the titration. And now stop the titration, and you have to measure the volume consumed by HCl. HCl වලින් කොච්චරක් වැය වුණාද කියලා අපි බලන්න. According to that, we will see the amount that you have added and amount that has been consumed. Using those two, you can find out the concentration of the sodium hydroxide. So you will learn this calculation during the practical session. So I explain this one. Solution accurately known concentration, that is known as standard solution. So the titrant is the one where we know the concentration. The other one is the titrant or analyte, which is having unknown concentration. Titrant reagent known concentration, titrant unknown concentration, and then so as I mentioned here, burette with a known conical flask with unknown concentration. So we are adding the known one into the unknown concentration solution dropwise and allowed to have a reaction. Once the reaction is completed, that point is known as equivalence point, but we are usually detecting the endpoint, which is just past the equivalence point. To detect that endpoint, we use indicator. So the reaction should be completed and there should be an indicator to identify the completion. And then for the titration, I told you we have to have non-concentration solutions. So those are known as standard. There are two types of standards as primary and secondary standard. So the primary standards are the one which are chemically stable, non-hygroscopicity, that means they are not going to absorb water vapor from the environment and going to be dissolved. ජලවාෂ්ප උරා ගන්න නැති ඒවා. hygroscopicity, okay? And POO easy to purify, have a higher molecular weight, have good solubility, be non-volatile, and fast complete reaction. This is because if such criteria is fulfilled, then we can measure it accurately with the amount that we are going to prepare standard solution. For example, if you use sodium hydroxide, so sodium hydroxide usually absorb water from the environment and it can dissolve. So therefore, it's not possible to measure the accurate quantity of a sodium hydroxide. Therefore, sodium hydroxide does not consider as a standard, primary standard. But when you get it sodium carbonate, it does not absorb water from the outside and we can measure it exact quantity of the sodium carbonate and we can prepare a standard solution. So I have given, so please keep in mind what are the characters of primary standard. It should be stable, non-hygroscopicity, pure and easy to purify, high molecular weight, good solubility, non-volatile. Volatile උනත් බැහැනේ. Volatile උනත් ඒත් අපිට හරියටම amount එකක් මැනගන්න බැහැ. Exact amount එකක් මනින්න පුළුවන්. ඒවා තමයි අපි primary standard එකක් හැටියට ගන්න. So the secondary standard are the one where we cannot measure the exact quantity due to hygroscopic nature or volatility. This can be standardized, but this can be standardized against the primary standard and we can find out the concentration. So this is the usual way that we are preparing the setup for the titration. So we keep the white tile at the bottom of the conical glass in order to see the color change clearly. And you have to use the stopcock. There is a point where we can control the flow rate of the burette. Stopcock, you have to use your thumb and the two fingers, so you will experience that one in your practical session. So this is how you had. How do I show you? So we'll show you that one in the practical session, how to control that one. As I mentioned, when you are reading the meniscus, you have to see the bottom of the meniscus, and it should be in your eye. And one side you have to control the stopcock, while the other hand is used to shrill the flask. So there are two important points, equivalence and endpoint. As I mentioned, equivalence point is the point at which stoichiometrically correct number of moles of each reactant are reacted together completely, but we cannot measure it by indicator. Indicator will measure the point which is just past the equivalence point. That is endpoint, the point at which the indicator changes a color in a colorimetric reaction. So so different indicators are there for the acid-base reaction, phenolphthalein, methylene rate. So indicator also acts as a weak organic acid. It gives the color, one color in acidic condition and another color in basic condition. So here, when you use the phenolphthalein as an indicator, starting point, so it has a kind of a colorless solution. And later on, you can see it's forming a light pink color when the medium is going to be acidic. So this is a good endpoint. This is far from the endpoint. So we have to stop your titrations at the correct endpoint. So here, this is that kind of a calculation. So without knowing the mole calculation, difficult for you to do, but somehow I'll try to explain it. So here it says that he has titrated 25 ml of sodium hydroxide. Here the known concentration is with the sodium hydroxide. So this is the glass. So here the concentration is 0.1 m. For molarity is given by m in a solution. So the molarity is the one number of moles dissolved in 1000 ml of 1000 milliliter of solution or 1 liter of solution. ද්‍රාවණයේ ලීටරයක දිය වෙලා තියෙන මවුල ගාන තමයි අපි molarity එකකින් කියන්නේ මෞලිකතාවය එහෙම නැත්නම් molarity එකකින් කියන්නේ. So that is one way of expressing the concentration of a solution. So we have added 0.1 m sodium hydroxide with 25 ml. And here it's having 25 ml also used up in titration. So here HCl, the concentration is not knowing, but HCl 25 ml has been used up at the end of the titration. Now it is asked you to find out what is the concentration of the HCl. So first of all, here we have to find out where you have to write the balance equation first. Otherwise, you cannot identify the number of moles reacting in the reaction. Sodium hydroxide plus HCl then sodium chloride plus water So according to that, oxygen 1, chlorine 1, hydrogen 2, both sides are balanced. Therefore, 1:1 the ratio. So number of moles of sodium hydroxide react with number of HCl are same. Both sides are same. Same number of moles of sodium hydroxide and NCl are reacted together. Therefore, we can find out first the number of moles of sodium hydroxide used in the reaction. So as I mentioned, concentration is given as 0.1 m. The molarity means number of moles dissolved in 1 liter of solution. That means, so 0.1 moles are now present in 1000 milliliters. 1000ක දශම එකක් ලීටර එක මිලිලීටර් 1000ක එහෙම නැත්නම් ලීටර එක දිය වෙලා තියෙන මවුල ගාන තමයි මෞලිකතාවයෙන් කියන්නේ. එතකොට 1000 milliliters will contain 0.1 moles. Okay. If I indicate as the symbols, milliliter. So here, mole. So into, so 1000ක දශම එකක් තිබුණා නම්, so you have taken 25 ml out of that. We are going to find out how many moles should be in a 25 ml that you have taken. මේකෙන් 25යි ගත්තේ මේ ලීටර්. එහෙනම් 25ක මවුල කොච්චරක් තියෙන්න ඕනේද? If 0.1 moles are present in 1000 milliliter according to the concentration, and if you have taken 25 ml, so you are going to find out how many moles of sodium hydroxide that you have used for the titration. Now then, this should be equal to the number of moles used up with the HCl according to reaction, as the ratio of the reaction is 1:1. So the HCl side, then you don't know the concentration. That means you don't know how many moles are dissolved in 1000 milliliters. ඔයා දන්නේ 1000ක කොච්චර දිය වෙලා තියෙනවද කියලා. So we take it as C. But you know the quantity used up in the titration, that is 25. So the only unknown one is the C, this one. So what is the answer? Can you give me the answer in chat box? What is the answer? So this side denoted the number of moles used up in the titration. If the 0.1 moles are in 1000 milliliters, and how many moles should be in 25 milliliters? And it should be same to the HCl moles used in the titration, as the reaction ratio is 1:1. 1 mole of sodium hydroxide usually react with 1 mole of HCl. So therefore, number of moles used in its titration in HCl, number of moles used in the titration should be same as the number of moles of sodium hydroxide. So we can get the unknown one as C. If the 1000 contains C number of moles, then how many should be in 25? And once you have both sides, so you only know unknown one is C. So the answer should be, what is the answer? So quickly you can give the answer in chat box. 1 second. Don't you have idea? C තමයි හොයන්න ඕනේ. C unknown එක. C අපි හොයන්න ඕනේ. අපිට දැන් තියෙන්නේ සමීකරණයක් equation 0.1 divide by 1000. But මේකේ මේ ලියන්න අමාරුයි. That's why it's difficult for me to write. I don't have touch screen. 25. Sorry. And that is equal to C divided by again 1000 into 25. So what is the C? You have to find out C. What is the answer? Look at the C. Anybody else? Yes. Others? Yeah, 0.1 molar is the one, because we can't say mole, because now that number of moles in 1000 milliliters. So therefore we can directly name it as a molarity. Molarity is denoted by capital M. Okay. Tomorrow you will learn them. Not 0.01. Answer should be 0.1. This is the answer. Answer C. Because 1000 to 1000, we can cut off 1000 to 1000. And then 25 to 25 cancel off. And the C equal to 0.18. So this one again we will discuss again in the practical session. So don't bother. Again, you can clearly understand. That's why I'm asked you to attend to the practical session. That is more important. Otherwise, you will be in a trouble with the practical paper. You won't be able to do these calculations. So it gets higher marks for these as we have only 3 practicals. So you will in a great trouble. Therefore, it is highly important to attend to the practical session. So we'll discuss these questions again in the practical class as well. Then regarding same thing, strong acid-base reaction. So you can see equivalence point. So the titration curve, if the sodium hydroxides are adding, and what would be the equivalence point. So here you can see if the reaction with sodium hydroxide and H2SO4. So according to the balance equation, now you can see you have to first balance the oxygen. So here oxygen 1, oxygen 4, 5. This side you have sodium sulfate and the water 4 and 5. And hydrogen 1 and 2, 3, but here it's 2. That's why we put the 2 in here in order to balance. If you place 2 in here, sorry. So here you have 2 sodium. So therefore, definitely you have to add 2 in here. So then 2 hydrogen, here 2 hydrogen, all 4 hydrogen. In order to make it 4, you have to again add 2. 2 by 2 oxygen, then oxygen should be 2 and here 4, 6 oxygen. Oxygen හයක් තියෙනවනේ. ඒකට 6 එනවා. ඒ විදිහට ඔයගොල්ලෝ balance කරනකොට all the atoms should be in an equal number. So according to that, you have to check both reactant sides and the product sides. So once you balance the equation, now you can see 2 molecules of sodium hydroxide react with the 1 molecule of H2SO4. Or 2 moles of sodium hydroxide react with a 1 mole of H2SO4. Therefore, in here, number of moles of H2SO4 used in the titration is equal to 2 moles of sodium hydroxide. Sodium hydroxide මවුල ප්‍රමාණය වගේ දෙගුණයක් ක්‍රියා කරන්නේ H2SO4 මවුල එකක් එක්ක. So the H2SO4 මවුල ගාන සමාන වෙන්නේ sodium hydroxide used in a මවුල ගානේ භාගයකට. So according to that, you have to find out the volume. You have to find out the the concentrations. Here, moles of sodium hydroxide is equal to sodium hydroxide 2 moles of H2SO4. H2SO4 මවුල ගාන වගේ දෙගුණයක් අවශ්‍ය වෙනවා. sodium hydroxide තියෙන මවුල ගාන H2SO4 used වෙන මවුල ගාන වගේ දෙගුණයක් වෙනවා. අපි මේක ගැන ආයෙ කතා කරමු practical session එකේදී. Then you will get the clear idea. Otherwise, you are in a trouble. Because without discussing the mole and molarity calculation, it's difficult for me to explain the things. So other practical session that we are going to do is the instrumentation method. One is the chromatography technique. In that case, we are using, it's a kind of a separation technique. So it has 2 phases called mobile phase and the stationary phase. Stationary phase is usually immobile, not moving. And the mobile phase is the one which is moving. So stationary phase usually can be a liquid or a solid. And it should be packed in a column or a planar surface, flat surface. Mobile phase is usually cannot be a solid. It is usually either liquid or a gas. So it is the one which is carrying the sample to be separated. So in your practical, you are going to do a paper chromatography. Here, stationary phase, is the one water molecule adsorbed to the cellulose paper. So chromatographic paper. So the water molecules absorbed to the paper is the one stationary phase. Therefore, stationary phase is a polar one, and mobile phase is a organic solvent, that is non-polar one. So you will prepare a kind of a jar like this, and paper, chromatographic paper, cut and dip in a mobile phase, not dip into the mobile phase, just touch with the mobile phase, and place the sample to be separated on the chromatography paper. So the chromatography techniques we can divide into several ways. So no need to discuss this thing in lengthy. So you should know that two different phases are there in any chromatographic technique, as stationary phase and the mobile phase. If the stationary phase is packed in a column, අපි නිකන් glass tube එකක තියෙනවා නම් stationary එක column chromatography කියන. ඒක අපි flat surface එකක තියෙනවා නම්, if you place the stationary phase in a flat surface, that is a planar chromatography. So the paper chromatography is a kind of a planar chromatography. And thin layer chromatography, you are adding to silica on top of the glass plate. That is a kind of a thin layer chromatography. So that is a planar chromatography. So now you are going to do a paper chromatography. So here the stationary phase is the water molecule absorbed to the cellulose fibers on the paper, and it is polar. Mobile phase is a solvent, which is organic solvent, and it is non-polar. And the sample may be a food coloring, so whatever the sample, maybe whatever the photosynthesis, if you are planning to separate photosynthetic pigments in a leaf or a flower or whatever the thing, so that would be your sample. So then you have to place the spots on particular spot with your sample, and once you place the chromatographic paper with your sample spot in a mobile phase, just touch and allow some time to get separated. What will happen? The components present in the mixture will be moved upwards along the with the mobile phase. As mobile phase is non-polar, any non-polar component present in a mixture move fast along with your mobile phase. non-polar එකක් තියෙනවා, ද්‍රව්‍ය නොවන දෙයක් වාගේ sample එකේ තියෙනවා නම් mobile phase එකත් non-polar හින්දා එයාත් එක්කම එයා ටක් ගාලා උඩට යනවා. If any component present in your mixture is a polar, it will move attracted towards the stationary phase, as stationary phase is polar. So therefore, as it is getting attracted towards stationary phase, its movement is very slow. Yeah, stationary phase එකත් එක්ක attracted හින්දා එයා තරම් උඩට යන්නේ නැහැ. Now, that is the basis of separation of component present in a mixture because of this polarity, or the attraction towards a stationary phase and the mobile phase. So this is how you are going to prepare your chromatographic paper. You have to have a pencil mark. So then what we are doing is, then we will calculate the relative mobility RF value, that is the distance moved by the spot and divided by distance moved by the solvent. So once the mobile phase is migrated, so you have to mark the solvent front first. And then you have to measure the distance from the starting point to that particular component. And then that is the distance moved by your spot, and the distance divided by distance moved by the solvent. So according to example, what is the RF value of chlorophyll A? If you got the idea, what is the RF value of chlorophyll A? How you can find out? According to the example, what is the RF value of A? Chlorophyll A. RF value. Now the chlorophyll A has migrated 4 centimeters. Your solvent plant mobile phase has migrated 12 centimeters. RF value is the one distance moved by the spot divided by distance moved by the solvent plant. So now calculate the RF value of chlorophyll A. What is the RF value of chlorophyll A? Yes, one of you have given the correct answer. So the RF value, how about the others? මේක අහනවා හොඳේ එක්සෑම් එකේදී මේක මේ විදිහටම අහනවා MCQ paper එකකටත් අහන්න පුළුවන්. So please try to get the idea. RF value, the distance moved by the solvent moved by the spot is 4 centimeters and the distance moved by the solvent plant is 12 centimeters. So the answer should be 1 over 3 or 0.3. 0.3 is the correct answer. So that is how you have to calculate the RF value, the relative migration. So with that you can identify, and just by looking at RF value you can compare with the standards and find out whether if your mixture is having a kind of unknown component, you can compare your RF value with the standard RF value of a set of the components, and you can have idea about whether your mixture is contain similar kind of component. But somehow you have to have similar conditions, you have to be provided as the standard has been separated. Standard separate කරමු similar conditions යටතේම කරලා තියෙනවා නම් ඔයාලට RF value එක standard එක compare කරන්න පුළුවන්. And once you get the separated, so you can identify if you have known sample, pure sample of each component, then you can run those pure samples along with this, your mixture. For example, if you are going to separate photosynthetic pigments, and if you have chlorophyll A, B, xanthophyll, carotene pure samples, you can run them along with your sample or a mixture, and then you can have a comparison with the relative migration. Okay, that's about the chromatography technique. And finally, we will do the spectrophotometer technique. And there, that is the last one. මම මේවා කරන්නේ ගිය පාර practical paper එක. Nowadays I'm correcting those. Actually, I have already corrected them. I have seen that most of them are getting less marks for the practicals. Even though they are getting marks for the theory paper, they have less marks for the practicals. So that's why I'm strictly stressing these points for you all. All the practical handouts we will upload to your elements. spectroscopy technique. So spectrophotometry is the one which can be used to measure the concentration of unknown sample with unknown concentration. Here we are using the basic is we are use the light absorption. So what is happening here? Actually, it has main component light source and the monochromator with the to select the one particular wavelength and the sample, and finally detector is there. So this is most widely used method for the quantitative tests of the chemical and biological sciences. Accurate and sensitive method. It depends on light absorbing properties of the sample being analyzed. So the basis of spectrophotometer is the light absorption, and a spectrophotometer is the one instrument that measures the amount of light that passes through the sample. So part of the light is absorbed by the sample, and a spectrophotometer actually measures the transmittance of the light which has been transmitted through the sample. Based on the transmitted light, we will find out the part of the light that is absorbed by the sample. So usually we have two different spectrophotometers. One is with the visible light range and otherwise in the UV light range. So visible light range, so the wavelength lies from 350 nanometer to 750, UV range 200 nanometer to 350. So if you are going to use the visible light spectrophotometer, the sample that you are going to be measured should be a colored one. Okay, otherwise the sample, if it is a colorless, it can colorless mean it does not absorb any light. So if you are going to measure UV light range, so then you can use colorless solutions to detect the concentration. Usually nucleic acids, proteins are measured under UV light range. So here you can see, if you are seeing a particular color means, if something is black means all the wavelengths in a visible range has been absorbed. Colors absorb color, wavelengths absorb. In a white light, we know that it consists of 7 colors. So all the colors has been absorbed. So therefore, then it looks like a black. All the colors has been transmitted, then it is a colorless or white. If anything we can see as a white, that means anything cannot, the white space, nothing absorb. Any color wavelength in a visible range is not absorbed in a white surface. That's why we can see it as a white, as everything has been transmitted. If something we can see it as a blue means, all the light has been absorbed, only blue color is transmitted. Blue wavelength is transmitted. That's why we can see it as a blue. So when you get the parts of the spectrophotometer, please keep in mind what are the parts you can ask. In your exam, so we will ask what are the parts of the spectrophotometer. It has to have a light source to emit the light. And there is a monochromator. Inside there is a prism where we can select the one particular wavelength, and that selected one particular wavelength is directed to the sample. Therefore there should be a container for the sample, and then there is a detector. So it will detect the light transmitted through the sample. Part of the light will be absorbed by the sample and part of the light will be transmitted and will be detected by the photodetector or detector. So then, so the part of the light is absorbed, part of the light is reflected, part of the light is transmitted through the sample. So the percentage light of the light transmitted to the sample will be measured. So we will have a blank. So assuming that all the light is transmitted, incident light is transmitted through the sample, so it takes it as I0, and transmittance is defined as the fraction of incident light which is transmitted through the sample. That is I divided by I0. So the transmittance usually expressed as a percentage. So then in order to find out the concentration of a particular sample based on the absorbance and the transmission, there is a particular law called Beer-Lambert law. In a Beer-Lambert law, it describes the relationship between absorbance, that is the light, part of the light absorbed through by the sample, and the concentration of the sample, and path length, that is the length of the sample container, or we say it is a Q rate. So the law states like this: for monochromatic radiation, that is single wavelength, absorbance is directly proportional to the both concentration of the analyte or the chromogen in a solution and the length of the light path through the sample. Accordingly, we can have an equation like this. So please keep in mind this equation. Absorbance is equal to epsilon into length into C, or the concentration. Epsilon is a constant. So absorbance is equal to epsilon, length, and concentration. So if you have given the epsilon value, if you know the path length, if you know the absorbance, then you can find out the concentration. So the absorbance is proportional, equal to the 1 over logarithmic value of the 1 over t. So based on this equation, you should be able to do a calculation. Shall we quickly do the calculation? This is very important. It is in your module. Let's go to the 9th section. Let's go to the chapter 10 and question number 9. Please do the question number 9. So only you have to substitute the values to the absorbance equal to epsilon LC. So if you have find the question, so please go ahead and put the answer into the chat box. Similar questions can be appeared in your paper. Okay, මේ වගේම එන්න පුළුවන් ගිය පාර ඒවටත් උත්තර ලියලා තිබුණ නැහැ. So it is up to you to so this is the one. Yeah, I got it. Sorry. So the 9th question, guanosine has maximum absorbance of 275 nanometer. So that means guanosine absorbance, maximum absorbance is at 275 nanometer. So we don't want that point actually. So if you are going to measure the guanosine concentration, you have to select the wavelength 275. That's all. But it does not involve in a calculation. So then molar extinction coefficient of guanosine is given, that is 8,400. So that is the epsilon. Epsilon is known as molar extinction of coefficient. And measure the absorbance value of guanosine is 0.7. So absorbance reading was 0.7. Path length is 1 centimeter. So L is given. Now it's asked you to find out what is the concentration of guanosine. Quickly give me the answer. Only you have to just substitute the values to absorbance equal to epsilon into L into C. Quickly give me the answers. Substitute the values. So only you have to just substitute the values for the equation. Absorbance equal to epsilon L C. So the epsilon is given, that is 8,400. L is path length 1 centimeter. Absorbance is given as 0.7 is the value. Absorbance does not have a unit. So the C is the one. C equals absorbance divided by epsilon L. That is 0.7 divided by 8,400 into 1. So once you do the calculations for this, you will get the answer. Okay. 0.7 divided by 8,400. So that is the answer for. So please simplify this one and find out the answer. This is the way that you have to do the calculation. Only you have to just substitute the values for the absorbance equal to epsilon into L into C. So please keep in mind what is Beer-Lambert law. So in a Beer-Lambert law is the one for monochromatic radiations, absorbance is directly proportional to its molar extinction, directly proportional to path length and the concentration of the chromogen or the sample is going to be analyzed. So when you remove the proportional mark, so the constant is coming, that constant is known as epsilon. Okay. And please keep in mind what are the parts of the spectrophotometer and the function of each part of the component, light source, monochromator, and the sample cuvette and the detector is there. Please go through that one. And then the calculation, and in your practical, so we'll show you how to plot the standard curve, and using a standard curve, how we are going to find out the unknown concentration. So we'll ask those things in your practical examination. In a paper chromatography, you should know what is stationary phase and the mobile phase, and how we are going to find out RF value. And if you have given a example, or if you are given data of a chromatography separation, so you should be able to find out respective RF values. And for the titration, you should know to have what is equivalence point, end point, characters of primary standards, characters of secondary standards, and then so we can give the certain set of data for a particular titration sodium hydroxide HCl. Usually this is the one you are going to do in a practical. And I will give some values, measurements, burette readings, and using that you should be able to find out the concentration of a solution. So those are the practical examination things that can be appeared in your practical paper. So please go through that and try to do the reverse questions. Then you won't have any trouble in your exam. So at least please go through the questions that I have given in the lecture notes. So I will upload certain model questions for you to get ready. And then I will upload certain reference material. Please go through them. Then there should be a quiz. So please give me a date for your quiz. කවද්ද quiz එක කරන්න පුළුවන්? After the practical session, are we going to have quiz? So please.
Okay, ma'am.
Okay. After the practical session, so we'll have a quiz. Then once it open, I will let you know. Before that, I will through a batch trip, and I will put the date into your LMS, not the LMS, WhatsApp group. So then, so the quiz and your assignment. So please discuss advantages and disadvantages of agrochemicals, use of agrochemicals in advantages and disadvantages of using agrochemicals in plantation sector. That is your assignment. So only maybe up to 4 pages enough, but present it in a creative form. So you should present your answer with a kind of a creative way, not just writing the points, but don't copy the whatever the thing available in the handbook. Just find out the information and have a creative way. Please present your assignment. That is what we are expecting. Go through the chapter 9 and pick up some point, extract some point important things, but present it in a creative manner. And maybe less than 10 pages enough. 5 pages, maximum 5 pages is enough, but present it as a creative manner. So that would be helpful for you to score more marks and without repeating the same thing in the chapter 9. So that is doing of the chapter 9 would be important, and finding out more information would be important in your exam point of view as well. So those are the things, and practical session will be notified later. So the date of the practical session, both Saturday and Sunday group, please attend to the practical session. That is important. So we'll give the handouts, and I will upload the practical handouts to your LMS. Anything else? Yeah. Yes, you can ask. Okay, you can ask your question. Assignment, yes. Advantages and disadvantages of using agrochemicals in the plantation sector. Discuss advantages and disadvantages of using agrochemicals in plantation sector. Only 5 pages enough, but with a creative way. Okay.
Ma'am, can we use photo?
Yeah, that's what I'm expecting. You can add some photos and you can find out more information. So you can present the not just photo in detail. Discuss the points. Yeah, you have to write. Maximum 5, less than it's okay, but present it in a creative way. Okay, anything else? Endpoint and equivalence point. Okay. Nodes means, let me show you. So we'll discuss those titration details, chromatography and the spectrophotometer analysis again in your practical session also. And your handbook also, the details are there. I will upload these lecture notes. First, you can go through the summary of the lecture notes that I have given for you all. And if you need further details, you can refer to the course module. But please go through the review questions, then you can easily understand what we have discussed. So the mole calculation also very important. So tomorrow you will study the doing mole calculation, finding out molarity. Those are important. Please go through them as well. Okay.
Ma'am, Saturday group students, Saturday should attend the practical session.
No. Usually the practical session will be on Sunday. Both Saturday and Sunday student should be attend on the practical session. Since we don't have large group,
Sunday only will be the practical session.
only one day we are arranging practical session. So once you come to the practical session, so we will divide you all into 3 groups, and then we will conduct 3 practical sessions parallelly and then rotate them. All 3 groups will be rotated, and within the day we will complete all 3 practicals. So one of you have asked me to share the lecture note again, show the lecture note again. Equivalence point, endpoint. So if you didn't understand, actually equivalence point is the point where the two reactors and the titrant and the trident, the correct number of moles of each reactant are reacted together completely, titrant and the titrant. For example, in sodium hydroxide HCl reaction, so 1 mole of sodium hydroxide react with 1 mole of HCl. So the complete reaction point 1:1 is the equivalence point. So usually we are adding known quantity of the, if it is sodium hydroxide, so the non concentration is with the sodium hydroxide, but we are adding known quantity, known volume will be added. We දන්න volume එකක් දාන්න. ඒ කියන්නේ known quantity එකක් එතන තියෙනවා කියන්නේ. හරි? So the point at, so 1 minute.